is very flat.
What's up, everybody? It's Friday, April 9th, 2021. This is Brandon, host of Brandon's Show. Hope everybody is doing good out there. What do we got in chat? What's going on, guys? Thin crowd to start the show off on Friday, as usual. Good to see you out there, though. Thank you very much. Flatzoid FE. Bill G. What's up, Bill? Ian Adams. Chrissy Heavey. Flat for Life. And Ute Hoob. What's up, Ute Hoob? And Khalil Underhill. What's up, Khalil? Good to see you guys out there. Hope everybody's doing good. Looking forward to the weekend, of course, and Friday night fights tonight. Hopefully we'll have some people in here who are ready to get crazy. That's what I'm hoping for. So we'll see how that goes down. Let me give you guys the link that I usually give, if I can find it today. Oh man, what is wrong with me? You know, I'm telling you what, I have been so freaking tired all week long. I think I'm fighting off a cold or something. But I'm a little out of it. There we go. And I'll pin that to the top. If you want to join the show, you can click the link in the Discord, not in the Discord, in the description for the video, and come on into the Discord. There's an invitation in the description. You can pop into the voice channel. You'll see it along the left hand side. Or just hang out with the chat trolls. It gets a little crazy in there sometimes. But usually it's pretty fun. So come on in. Check it out. You don't have to talk if you join the show. You can come in and listen too. Quite a few people do that. So that's all good. Let's see what else is going on. I don't know. But Jeremy's in the Discord. Let's go talk to Jeremy. What's up, man?
About to eat pizza with my family, so I can't really can't talk.
Oh, okay. All right. No problem.
Is this live? There's no one's at where they at? Oh, here we go. Flatzoid, what up?
Flatzoid's here. What's up, Flatzoid? How's it going?
Hey guys.
Hey.
I'm always missing the show.
Yeah, how you been, man? Haven't seen you on in a while.
Yeah, it's late. That's why I'm always sleeping.
I don't blame you for that. Well, that's cool. Yeah, I've seen your couple videos you put out recently. What are you thinking about these days, Flatzoid? What's on your mind?
Nothing. Just doing the same old.
Making fun
Having
of
fun.
Dr. Bob? I see.
Yeah.
Yeah, he's fun to make fun of.
Yeah. Yeah, but it doesn't. He just can't accept. And it's the only thing.
Oh no, he's a true believer. Bob is a true 100% by the book believer.
Yeah.
Absolutely.
Now I'm just trying to get Rumpus to understand that tangents can't curve.
Yeah, it's amazing how they can twist straight lines into curves and all that shit.
They've argued with me that tangents can curve. Like Dave said, that
even though you
tangents can curve.
I put a definition in front of their face. It literally says straight line, and they don't read the straight line. They just read tangent touching a curve. That's all they read. They ignore the straight line point.
Dude, they've argued before that straight lines are infinitely small curvature. I mean, this crazy shit.
Yeah.
Oh, okay.
Yeah, I don't know what geometry these guys study.
Right. I've got your video up. The doctor is bobbed, and I shared that link in the YouTube. So check out Flatzoid stuff. He puts out a lot of videos. And Dr. Bob's been hanging out in our Discord quite a bit lately. In fact, he was the last one to comment in there, and I just hope he's seen your video. I'm sure he has.
Yeah, well, he knows actually. Not that he's a.
Oh shit! I think you just cut out.
But yeah, and this actually just started. Can you hear me now?
Yeah, now I can. Yeah, it was just very brief.
Yeah. No, he knows why I did this video, because he told me I was lying when I did the equinox because he says he measured the Earth's radius at the equinox, and I told him, "Yeah, did you take refraction into account?" He says the sun doesn't refract.
Uh-oh. That's not correct even according to their model, right?
Exactly. Because I did a video showing where I did the equinox. The sun set 25 degrees off target. That's a flippin' lot of degrees.
Yeah, I don't know if you've listened the last few days, but we've been talking about the sun a lot. And the subsolar point.
Tell us how you feel about it, Flatoid, about the subsolar.
I would like to see it. I mean, I'm also like everybody. I just want the truth. I don't care what shape the Earth really is. I just want the truth. And if it's going to help me, I've got a lot of things to relook at. That's all.
Yeah, it's a good approach, man. I mean, you got to collect the data and look at it. That's science, right? Collect the data and try to figure out how things really are. Not a very good definition of science, but you know what I mean.
Yeah, I get what you're saying there.
You can't just sit back and
it's not natural science.
Speculate, right?
No.
Yeah, so I want to see it too.
If you're honest with yourself.
What's that?
Yeah, if you're honest with yourself, if you're honest with yourself, you just want the truth, no matter the shape.
Exactly. But yeah, some people seem to be worried about it. I'm not worried about it. In fact, I have no doubts that the sun is close and local, and I've seen zero evidence of any actual curvature. Well, I won't say zero evidence, but I haven't seen anything that proves to me that the Earth is curved. All of my experience on Earth, practical experience, is level is horizontal. Water is flat when it's still, etc., etc. Never had to take curvature into account for anything. Pilots don't have to take curvature into account. Pilots don't have to take rotation. It just goes on and on. And when I look up at the sun, it just looks close. You know, if there was no such thing as the heliocentric model, and we had been living here our whole lives, and then someone came along and said, you know, the sun's 93 million miles away, I think everybody would be like, you're fucking crazy. That thing's not 93 million miles away. What are you talking about? But that's just my personal opinion.
Yeah, well, what you gonna trust more? Your senses, that we do not feel movement, we can see the sun close by, or someone's telling you it's many millions of miles away, and you're actually spinning while you're standing still. I think I'd rather go with my personal observations. Thank you.
Exactly. Especially since those in power, those in positions to influence what scientific doctrine throughout the centuries have again and again proven themselves to be untrustworthy and wrong about a lot of stuff. They just think that they're correct about everything right now because they haven't been proved wrong. They thought the same thing back in 1900. They thought the same thing back in 1800. It wasn't at any point in time where they didn't think that what they thought and what they were telling people wasn't the truth. Oh.
They've never been right. They think right now is the time we live in where they got it right this time.
Right. Exactly.
Yeah, you just go back to the drawing board. If you don't get it right, you try again.
Yep. You know, and that's cool if they're upfront about it, and you know, some of them are, and say, well, this is the best that we think. I hear them say that sometimes, but I don't know. I'll choose my senses and my own experience, the empirical data that I've collected over my lifetime, over some fantastical story that I can't verify. Anyway, so what are you doing in this video, Flatoid? I'll share my screen so you can see which part I'm at. You've got a flashlight. And you're kind of walking behind a paper with 2 black lines on it.
Oh, I did. Oh, this one's on the flat Earth. No, is it the first part or the second part? Because I did two. One representing the globe and one representing a flat Earth. Oh, this is the flat Earth one. If you go a bit back, you
Okay.
see that would be a mountain representing a mountain. That would be the sun that's setting in the distance.
Okay.
This is the globe one. I think it'll be better if we get in context if we go back to where I think, yeah, that from there. This is me taking observation with the sun already set behind the so-called blockage. Now, when I turn, if you see where the sunlight is hitting on the clouds, it's still hitting on the top and the bottom of the clouds. And I turn 180 degrees behind me, and the sun is showing on those clouds as well. If it was on a globe, you wouldn't get the light hitting everywhere because it's got a physical blockage. So I just tried to demonstrate it, showing you can only get on a flat surface. You see that's 180 degrees behind me after the sunset.
Okay.
So if it was a globe with a physical blockage, why is it lit behind me where it's further away?
Why is what? Say that one more time.
The clouds in the mountain is lit from the sun. That's behind after the sun has set. If it was on a globe, you would have a physical blockage and the light wouldn't reach it. It would be blocked away.
Oh, gotcha. Okay.
So I was just trying to show it's all got to do with your limited angle towards the sun's location is why you get a sunset.
Gotcha. Okay, so that's what you're just doing a demonstration here to kind of show the concept.
Correct.
Your video reminded me of something that I have been meaning to talk about, which is as you watch things go away from you, like a plane or even clouds that are going off into the distance, and you look at them, the angle that you're looking at them, it's almost like you're seeing the bottom, like the bottom is facing you. Oh, this is going to be hard to explain. Shit.
No, I understand it's your angle towards the bottom of the clouds. It's like it's tilted towards you almost.
Right, and I've seen people who think that you're looking at the sides of the clouds, but I think you're looking at the bottom. Let me see. I wasn't prepared to talk about this, but that's okay. Maybe I can find a good picture here. Okay, yeah, this is a good one right here. Let's see if I can make it bigger. All right. So
you see, that's the clouds going into the convergence point. Then it gives that effect.
yeah, it's a pretty cool picture actually. So when I look at these clouds, it looks like they're going down at an angle, but also it seems to be presenting the bottom of the cloud. So this part right here, this light part, is that the bottom of the clouds, or is that the side of the clouds that we're looking at? Because it seems to me that those are the bottoms of the clouds.
Yeah, it does look like it. But I think it also depends on the angle you're looking at it from.
Yeah. And some people will try to use this type of picture with the clouds and the sun's lighting the bottom of them. And actually some of it is lit more on the far away side. But as some kind of proof of the globe, which is ridiculous because the angle the light is coming in is going to bounce off of water or the ground, or it's going to light up really thin clouds. I don't know how you could possibly think that it's a real stretch trying to use that to as some kind of evidence for the globe, in my opinion. But there's something with perspective, the way that perspective distorts things. Like when you see a plane go off in the distance. Let me see if I can bring up a good one. What are those things called? Contrails?
Yeah, it's better when they're launching. I mean, they look like space shuttles, dude, way off in the distance. They're going exactly straight up over the horizon.
Yeah, you know what I'm talking about, Brian, right?
Yeah, till they get about 70 degrees, or till they come up a long way. They look like they're going straight up, dude. When I was young, I thought they were space shuttles, literally, like, because I'm about 100 miles from the Cape.
Right, exactly. Like this one that's on screen right now. I don't think that this plane is flying, at an angle up into the sky. It's flying horizontal. It's too bad we can't see more of the context on the ground. I'll find a different one. And it looks to us like it's going straight up into the sky. It looks like it's going at an angle, but it's not.
Yeah, it's quite a deceiving angle.
It's very deceiving. I agree.
Yeah, every angle looks different, man. It's weird. In fact, I recommend anybody who hasn't done it, find a plane and don't waste your time until you get one coming directly at you or real close to it, and watch what it does from beginning to end. And it's something else. It makes you consider that you'd have no clue what the hell something up, twice that high or 10 times that high is supposed to do, because it doesn't look nothing like what it does.
No.
Well,
go ahead.
I've seen some planes go from my left to my right side of the view, and you can see it's literally straight line. But then you get another one that comes from behind me forward, and it literally looks like it's dipping down. So I think angles have a lot to play a part of the view of it.
Yeah, I live by the airport in my house, but I try to get videos every once in a while of a plane going over. I'm like, okay, yeah, that looks good. This is it's very difficult to film that phenomena and get the full context of it, as opposed to what you're seeing with your eyes. But like this one, these look like they're descending into the ground. Now that's how perspective works. This is no big revelation. But you are seeing, what you are seeing is, if we were to take it literally, you are seeing a plane fly into the ground, into the horizon, or ascend from the horizon and up into the sky at an angle. That's what you're seeing. Now that's not what's happening. We know that this is parallel. Probably we'll just assume this is parallel, but that's what it looks like when it's parallel to the ground. But you are seeing a distorted view of reality. Now the ballers think that this will match geometry, and that's where they get their curve from.
Yeah, but even that, it would mean it's much smaller than what they're talking about, because look at the distance. If you have
look
to
at
take
the
that,
chemtrails.
Yeah.
Their geometry breaks down after about 8 miles, maybe 6 miles, 8 miles. Their geometry screwed. Their trig, I mean.
Yeah.
Look at a cloud. A cloud's 11 miles away, and it's sitting over the water, or over the tree line, and it's only like 10, 11 miles away. It looks like it's about 50 or 100 miles away.
The Earth is very flat.
And we also realize, because they also say, why does the angular size of the sun change if it's going in a distance? Well, you look at this, the angular size is also not changing of the chemtrails. I think it appears to go behind the limited deck of angle before it has a chance to change its angular size.
Yeah, I think there might be something with optics where for some reason the sun and the moon don't appear to change that much in angular size. I know they love to use that argument, but it's a really tough thing to prove what's happening between the sun and us going through all that atmosphere, because it is going going through an increased amount of atmosphere as anything moves away from us parallel to the surface of the Earth.
Especially when any reflected light, like the guy just did a little 1-minute video, I forgot who it was, I'll think of it in a minute, but showed an infinite light source reflection. It never changes size, no matter what you do. And the same thing with focal points. They don't change angular size. They just say that shit. Either they're willfully ignorant, or, I mean, either they have no idea, they ain't looked into the subject, but light has got multiple behaviors. They know it. I think they throwing the basic arguments out there.
Yeah, it might have something to do with light. That's interesting, exactly. A difficult thing to prove either way, right? Unless you know the exact distance to the sun. Maybe that might not even do it.
I just left Jose's, man. I'm freaking exhausted, dude. Arguing with people, and Jeremy was there, and he backed me up some, man. Going over Blue's Cavendish. I can't get them to even accept the fact that, you know, he sit there and he made a comment kind of like Bob from Globebusters when they give him hell about that there's a 15-degree-per-hour rotation. He doesn't say whether it's the sun or it's conclusive or anything like that. Well, Blue, I got a soundbite on him. I made a video, the one on my channel, Flat Earth Test, that says that proof that mass attracts mass. Is that it's probably about a 10-minute video, but it shows him talking about how he said at this point in the project or experiment, I proved that mass repels mass. And so I know he was just joking and everything, but he did prove, you know, that mass repelled mass until he put some copper foil up. Then he said how he had two wires going to a certain point, and other two wires he had to adjust the grounding rod and all this stuff, and he got it to. So all this stuff, and I'm trying to get him to acknowledge. Look, what did you vary? You know. So when you put copper foil up, what did you vary? And they will not answer that question. If it kills them for 2.5 hours, I tried just throwing it in there here and there to get them to admit, what did you vary? They won't say we varied electrostatic. You know, they'll go off on a rant talking about, we eliminated this, that. But so when they mess with the grounding rod or the grounding wires and stuff, they won't admit they are varying. The only thing they're varying in that experiment is the electrostatic potentials, and they're getting variations in how the lead balls behave. And it just drives me nuts, man.
Yeah, well, Brian, before I got muted, that's why I left. That's why I posted that thing for. That's why I posted that thing for Blue to show him, because he said you can be around it, and those papers specifically said you're not allowed to be in the same room. So if he's honest and actually keeping with the Cavendish, he won't be in the same room.
Yeah, he wasn't very honest about that.
Speaking of the Cavendish, I asked him for his formula today. Brandon, you're good with math. If I give you a formula, which is not mine, which was from a science channel to calculate the force of gravity, it's based on a pendulum swing. Now, Brian, I posted the information on one of your channels on how to do it. And basically what you're doing is you're taking the rate of oscillation and dividing it by the time to get the constant cycle per second. And then what you're doing is you're taking one constant length string and using a calculation to get the rate of gravity. Well, it says that if I put whatever weight at the end, it won't change the constant of gravity. But in reality, it does, which I just done here. So I have some numbers to give you, Brandon, if you're interested.
Sure.
Yeah, you're sitting there telling them you did it.
Not in any formula.
You're telling them you just did it. They wouldn't find it. When did you post that?
But the hook, because this DJ revolves it.
So I posted on I think today on one of your newer videos, but I gave you some results that I did.
Cool.
So they use a formulation called which is 4 pi squared times it by or multiplied by the length of the string divided by the cycles per second squared, and you'll get the rate of gravity. This is what they say. This is not me saying, this is the channel. So I figured I'd put it to the test. And I take one length of string that's constant, and I change from a nickel to a quarter to a guitar pick. And then I calculate the rate of oscillation based on that, because they're saying it shouldn't change. It should be a constant 9.8 meters per second. And the reason why they say that is because if I was to go to another planet and use the pendulum this way, I'd be able to detect the gravitational difference between Earth and the planet, whether it's 1 times greater or 1 times less, and so forth. So, for instance, when I do an oscillation, like a pendulum test on the rate of cycle versus a quarter versus a pick, I get a rate of 1.1 1 second per cycle, or sorry, 1.01 seconds per cycle for a guitar pick on the pendulum over a 30 cycle times. So it's sorry, let me rephrase that. To get the cycles, you divide it by the time divided by the cycles. So I count 30 cycles and however long it takes me to do those 30 cycles. And I end up with 1.01 cycles per second for the guitar pick, as an example at the end of the string, which works out to be 11.92 meters per second squared. And then when I do the quarter, it works out to be 10.62 meters per second squared. So I don't have a constant rate here, and the rate changes based on the matter that's involved in the oscillation. So what I decided to do is ask Blue his formula for calculating the isolation. So instead of telling me, he's like, well, do you know what a period is? Do you know what to do that? The point is they're calculating an isolation over a period of time. Whether it's vertical or horizontal, it's still an oscillation pattern, right?
Yep, that's exactly what they're measuring.
Yep, and not even varying it. You know what I'm saying? Not even varying it.
So I just wanted to show this, and he says, well, you get different results vertically to horizontal. I says, well, wait, you're telling me that gravity changes its force then based on vertical versus horizontal? Right? So it's an easy test. I used a 12-inch string, and I videotaped it and played it back with a videotape and a stopwatch. And in this example, I did 5 tests in a row, and I would divide it by, you do 5 successions. You can do more to get a variable, right? To get a constant of the variable numbers you get. So
agreed.
So for example, on the quarter, I would get to complete 30 cycles, I would get 31.6 seconds, 30.125 seconds, 32.97 seconds. So, and I would take those all up, add them up, and then divide it by how many tests I'd done. So I would like somebody to show me Blue's formula and how he calculated the cycle and the time of it, and then deriving, because that's what you have to do. You're looking at the cycles in an amount of time, right?
Yep.
This is how you get the formula. So I done it. I just did it on the vertical and not the horizontal, and I just got silence out of Blue. So if we just look at the formula and how they're doing it, you'll just easily see it's full of shit.
Yeah, Data, but that's why he got so angry with me and called me dishonest when I say we got video footage of him actually touching his apparatus. So he has induced the oscillation by actually touching his apparatus. And that's why he doesn't...
Plus he walks in, every time he goes to set it, he walks in.
That's what I'm saying.
Watch this shit. He walks in and sets it and walks out at the same exact rate. He comes in at the same speed. He's sitting right there at that one spot at the same speed and circles around and walks out, doubles back. All at the exact same speed. He's got it set up, but my point is that, like I told them, I could take all the parts you have there and the way you have it set up and just move it around a little bit and make a great earth battery. If you give, in fact, a really good one, because he's got a copper rod like 8 or 10 foot in the ground, and he's got some tungsten wire. Before that, I think he had copper wire. I forget. But he's making all these changes, but he won't consider any of them variables until it's all done and doing what he wants, and that's what he considers the starting point of his experiment. So before he added the copper foil, he said that he had put lacquer on it, and Cavendish had his legs grounded straight into the ground. He had them dug in the wood. He had his apparatus sitting on wood and going straight into the ground, and he was talking about the moisture in England at that period of time in the late 1800s or some shit, and how his lacquer must have dried up. So mass repelled mass. He said. So at that point, he proved that mass repelled mass because his balls repelled away from each other, and then he put copper foil on one side of it, and so eventually he got it doing what he wanted it to do, and then he starts his results. Then he starts recording his results, and to me, that's bullshit because that is a variable. If you checked it in the mass repelled mass, and then you added copper foil, and it did something different, then that's a variation, and that would be a variable. But either way, he already had the masses moving, and he keeps calling it nothing but mass when he's just using lead. And that's one of our biggest points is we want to see something non-conductive. And he's like, what? When I talk about the wires, I'm like, use something besides the wire. He's like, what are you going to find non-conductive for wire? I said, dude, how about thread, twine, fishing line, monofilament, nylon, anything. He's just so locked into the books and the certain method they can't think for themselves. It's sad, man. It's like arguing with robots.
That's a good way to describe it. No offense to them, but they do go by the book. So it is like arguing with the Wikipedia page in most cases.
Yeah, and they're not even smart.
The problem is, Brandon, I've proved several times already that if I take their own stuff and I present it to them, they say it's wrong. But yet I got the stuff right from a mathematical science channel, and I'm using their formula. And then I present, like I did today, to Blue, and he's like, "Well, that's wrong." Okay,
Yeah.
I got it right from the horse's mouth, and you're denying your own modern science.
Yeah, do you think Dr. Bob will come in here and actually discuss with me? Because he's saying I just heard 9 minutes of nah.
He might.
Yeah, I told them, man, you don't got to use every substance on Earth, but just try it with using non-conductive. I told them the way they powered the early telegraph system, as the poles, they had copper coils of wire, coils of wire in the ground. That's how they drew the power, the current. And he's sitting there trying to act like I don't know what static electricity, he's like, well, what is static? I'm like, still, I know it's not a current, but it's trying to be. If you have it's electrostatic potential. If you have a wire into the ground attached to a conductor, then that's one half of a circuit, basically, right? And if you have four other ones, and then what I told him is you take lead plates and you separate them with a piece of paper or anything like that, paper towel, notebook paper, or a rag. Well, you put a meter on them, a voltmeter, and you get current. That's how they make batteries, car batteries. Of course, they add lead dioxide and sponge lead and shit. But besides that, and they put it in acid, sulfuric to boost the charge. That's all to boost the charge. The point is the lead, one of them automatically acts as the negative, and one of them acts as the positive. And they'll accept the current just like that. So the point is that the fact that he says he's got them all grounded to the same copper rod in the ground. So they're pulling charge out in the ground for one, and for two, it could be the different sizes of the balls. Because he said he had them two tied together. I got to listen to his video again. I think I got him called out. He's got two of the lead balls bigger and two of them smaller. So when you put the plates together, that ain't hanging up attached to wire, one of them acts as a positive, one of them automatically acts as a negative for some reason. And so that is what I predict is happening with this Cavendish. And if you get all the shit just right, you get the electrostatics just right, then you get the formula he wanted. That's why I think it took Cavendish so long, because I think just like with the Planck's law and all that stuff, where they admitted they already had the formula, they already knew the equation they wanted. They just boggled the numbers to get what they wanted. I think that's pretty much what they did with the big G constant. They already knew what they needed to fit their model, and then they just tweak the apparatus until they got it to do exactly what they want. Because it's everything's got to be so perfect, man, and just right sizes, copper foil here, the ground, and everything's got to be just right to get the results they want. And then they say, okay, it's finished, and here's the mass attracting mass. After doing all them electrostatic variations, they get done and say, ta-da, mass attracts mass. It's retarded.
Hey, Brian, you really are out of your depth when you're talking about electronics and electrostatics and electricity. You really shouldn't be trying to discuss any of this. You don't know the first thing.
Was anything I said false, though, George, from what I do know?
So what?
Did anything I just say, was any of that false? Can't you put two plates of lead together with a separator and get a little, like a milliamp of charge?
No, you have to have a proper electrolyte.
Okay, I already showed that you could do that. Okay, I did that live on Jose's show. Okay, and
you gotta have,
but it was a current. Okay.
And You have to have a good electrolyte, the proper electrolyte, in order to
get a good charge. Yeah, I understand.
Will you shut up a minute and let me speak? My God,
You're talking shit, George. I already showed it.
George.
Channel, dude.
You can
were talking like a dickhead, George.
Can you get any useful energy or power out of it? Without a proper electrolyte, you cannot. All you can do
Right, but you will still get energy,
man.
man.
Shut the fuck up. My God, you're...
Well, quit fucking lying, dude.
No, I'm not lying. You can get a potential get any useful work or energy out of electrostatics. It's a conservative force field that does not, you cannot draw power or energy from an electrostatic field.
Guess what, George? He got 2 lead balls to repel each other before he had a copper foil, dickhead. So shut up.
You can create a force, but you cannot draw power from an electrostatic field, Brian.
You can create lead balls repelling each other. Can you not?
Can
you not create repulsion and attraction?
Oh my God, you're just too stupid. Goodbye.
He won't admit it. He won't admit it. Can you not create repulsion and attraction, George? It'd kill him to admit it, folks.
He knows you can, because that's what Coulomb did to the Cavendish experiment 10 years before.
George, why won't you answer that question? I'm just curious. It seems like you're acting like it's really a stupid question, but...
What question do you want me to answer?
Brian, ask it again.
You said you can't get a useful charge, but I said, can you get attraction and repulsion?
If you have opposite charges, but if you put an electrostatic...
If you have like charges, what happens if you have like charges, George? George, you're about to lie about it. You just said you have opposite charges. Opposite charges attract, like charges repel.
Brandon, why don't you mute Brian so I can answer the question?
It's Friday Night Fights, George. It's hands off.
No, I'm not going to sit here and fight to be heard. That's bullshit.
Well,
bye, dickhead.
That's the way it is on Friday nights,
fighting.
George. It's kind of a free-for-all, unless
Okay.
it's really crazy.
All right, fine. Fine. If you want me to answer the question, then
I'll back off, George. I'll back off.
There he goes. He'll back off. Go ahead, George.
Keeping quiet, George. You can talk.
Did you guys know? Did you guys know in 1944 the
Just
V2
keep
rocket
doing what
actually
you're
struck
doing.
London City?
Slowly but surely, the truth
Hey,
is
were you
getting
listening to what was going on just now?
I don't give a fuck about what George has to say. He's a lying piece of shit.
Well, you guys remember George also thinks straight lines curve, so it doesn't really matter what he says.
Guys, I'm sorry for cutting him off, but when I asked him this specific question, I said, okay, so.
Thank you, Chrissy. $5. Just keep doing what you're doing. Slowly and surely, the truth is getting out. Thank you, Chrissy. I hope so. And shout out to Dan the Waterman for the $10. Thank you so much. I appreciate it, guys.
But opposite charges, I want to say the like charges repel. Okay, so you don't need just charge. That's what attracts, yeah. But I asked him specifically and repeated it.
Brian, that's if you wouldn't let me answer, you're misquoting.
Yeah, I'll back off, George. I'll back off in all fairness.
You're saying things I did not say. You just keep interrupting. You don't let a person complete the thought. You're just a rude SOB.
Take your own advice, George.
Kind of hypocritical because you're one of the rudest guys I know.
Yeah, hey George, you're the guy who has like a final or ultimate solution for flat earthers, right?
I'll back off, George, and let you answer. Sorry, man, but I'll just get a little passionate. I just went through it for 2.5 hours because they wouldn't answer a simple question. And then we just asked you a simple question. You made it sound like a dumb one, but you said you couldn't get any useful charge out of them. And I said, could you get attraction and repulsion? And I was expecting you to say, yeah. But,
I did not say that. I did not say that. I said you can't get any useful energy or current. I did not say charge. All right. Opposite charge. If you have two opposite electrical charges, a positive and negative, they will attract one another. If you have two like charges, the fields will cause them to repel one another. But if you put an electrostatic shield between them Doesn't matter if you have two positive charges, two negative charges, or a positive and negative. You put an electrostatic shield between them, which is often referred to as a Faraday shield, and you ground it. You make the fields terminate on that copper shield, and the fields do not interact with one another, and you neutralize the forces. There will be neither an attraction nor a repulsion between the charges if there's an electrostatic shield between them. Done.
Okay, I'd like to respond. And sorry for interrupting earlier, but he did that, and he charged them all. I mean, he grounded them all, and then they repelled. Okay, and then he said that he didn't have enough moisture in the legs of his apparatus because his lacquer dried up. So he put copper foil. So apparently when he thought he had the electrostatic potential zeroed out, it wasn't, because he had to add copper foil to one side of his apparatus, and he got it working just right. That, to me, is another change in the electrostatic potential. So there's stuff he didn't know about or something he didn't have set up just right. My point is he's changing all this electrostatic potential shit and drawing and grounding straight to the earth.
Yeah, Brian, he could have induced a magnetic field inside the apparatus. He could have actually induced the magnetic field inside there without him realizing it. Just because he is grounding the casing doesn't mean that that's got no magnetic propulsion inside with the actual lead balls. They're not grounded.
Electrostatics and magnetics are different. I don't know what you're talking about magnetics now.
Got magnetic propulsion. Electrostatics is a magnetic propulsion.
Yeah, if you got a charge and you
electrostatics and magnetostatics are totally different. They're not only changing electric and magnetic fields have interactions, not static fields.
Hey, I got a question.
Yeah.
Oh, I thought you guys were done with that exchange. Sorry. Go ahead, Flatsoid.
Go ahead, it's fine. I'm just trying to get Bob inside you, but he's running away from you.
Stop in, Bob.
But do you understand that, Flatzoid, that static fields, static electric, and static magnetic fields do not interact? They are not related to one another. Their sources are totally different.
They have the same
I can make a magnet out of either one, George. I can get repulsion and attraction out of either one, George. And when you're talking about grounded to get rid of the electrostatic, yeah, if you get
when you produce a magnetic field from a current, that is no longer electrostatics or magnetostatics, because you have moving charge. Moving charge produces a current. You are no longer in static field conditions.
My point, George. How does he know he's not doing that? He's not inducing a field.
So he was getting repulsion. He put up some copper foil, and all of a sudden that charge, has nothing at all to do with it. And then he was getting the wrong attraction, and then he grounded it a different way, and that also had nothing to do with it. The whole time it was just mass, George. I mean, can you be honest and think outside of your textbooks?
What are you on about now? I just came to talk to you about electrostatics, and what you were saying was not correct. That's all.
All right.
Now, if you want...
So was I not correct? Was I not correct in saying that he said in his apparatus at that point he proved mass repels mass? Okay, he said it. It's in my video.
I'm not talking about it.
He was just. Let me finish. He was just joking, but then he put up copper foil. Okay, what is not true about all this stuff? Okay, I just repeated what I said, and he got the balls to repel. Then he got him to attract after putting up copper foil. He changed electrostatics. You can call it whatever you want. That's what he changed.
You're talking about some Cavendish experiment, and I am not. You are assuming that I have seen the same videos or the same experiments as you, and I haven't. I have not been following any. Well, you shut up, Flatzoid. I have not been following any of this. All I was commenting on was your statements regarding electrostatics, which was not correct.
And you say You don't know what you're talking about, and yet you come and you want to correct him on something you don't know what he's talking about. Very, very clever.
No, that's not what I said, Flatzoid. I heard Brian talking about grounding and how electrostatics behave and getting useful energy out of batteries made out of taking lead and separating with paper. And I'm just saying that his understanding of basic electricity and how batteries work.
George, I make batteries, George. I make batteries. When did I say useful energy? When did I say useful energy? Why you do that, man?
Anyway, hey Bob, are you going to be man enough to come and face me, or are you going to carry on running away? Bob.
What was I gonna say? Yes, I had a question, but first, Blue Ford J 799. Is George a flying robot? Oh, that's not flying. I think it is. Is George a fucking robot? George, comment?
Why would I comment on something like that? Come on.
George is fucking a robot.
That's a good, honest answer.
George, does things like that attract to you or repel from you?
What is what?
Things like that attract to you or repel from you?
What attracts or repulse?
Whatever you put out, right? Whatever you put out in the universe comes back to you, right?
What? You're not making any sense.
George,
No
you know Einstein's theory before he came up with theory of relativity? He had a theory with magnetism and electricity combined, right? As the actual combining forces. What happened with that? Are you sure?
No.
Are you sure? Can I read you something from 1929 documentation? I'm going to read you something, okay?
1929 was after the theories of special and general relativity.
So a new theory by Albert Einstein that unites gravity and electromagnetism is one set of formulas arousing great interest with the world of physics. Einstein has been working on a new theory without interruption for the past 10 years. 4 years ago, he reported success, but then he said he discovered a flaw in his reasoning. A theory consists of a set of equations demonstrating that gravity, electricity, and magnetism are just different manifestations of the same basic force. It is confirmed it will be a major step towards Einstein's goal of uniting all basic forces of nature into one unified field theory. Physicists who have seen preliminary versions of the theory say it requires long and careful study to verify, but could it even be of greater importance than Einstein's theory of relativity? What do you have to say about that?
He was never able to unify gravity and electromagnetism. No one has yet. It's called the Tao, the theory of everything. That's what many physicists are working on. Nobody's been able to do it yet.
That's isn't that the M theory with Stephen Hawking?
String theory is one of the approaches, and the standard model is another approach.
So, question for you:
nobody's done it yet. So why even argue about it?
So, question for you: so, how can they know what's going on if they can't put electromagnetism and
they can't think outside the box. They'll never figure it out unless people like George would.
So how come they're negating electromagnetism then in all of it?
What?
If they can't add it in, they can't make it a complete theory.
No, it is.
It is now.
Of the four fundamental forces, 3 of them have been unified. Gravity has not been brought into a theory of everything. The strong force, the strong nuclear force, the weak nuclear force.
How accurate can they be that if
they can't? And let me speak.
How accurate can they be if they can't unify all of our natural phenomena together?
The strong nuclear force, the weak nuclear force, and electromagnetism have been unified into one theory. But gravity is still the holy grail that hasn't been merged into it yet.
Because it hasn't been validated, that's why.
There you go.
No.
Yes, George.
No.
Okay, what's
They
the
keep,
hypothesis
they
for
keep, they
gravity?
keep
George?
adding. They keep adding dark matter, dark energy, dark fluid. George.
Sorry, George. What's the
And
hypothesis
your
for
point
gravity?
is what?
So how can they know shit if they can't actually put everything that they observe together?
Well, that's what we're working on. We don't have a complete understanding of
So
So
it's not
it's
science
everything
then.
that we
it's
observe
one
in
big
the
guess,
universe.
right, George?
Say what?
One big guess, then.
No, it's not a guess.
Hey, Data.
Okay.
It's okay. Let them
yeah.
have their dark stuff. Let them have their dark stuff. We got our dark stuff too. We got our dark. Let's see, dark optics. You know, we know that there's a solution to Polaris, 10 degrees, but you know, with just a placeholder for future. So anything that we can't answer, dark sun theory. Let me think of some more.
Well, Brandon,
I like
you
that.
do know
I like that.
you do know that gravity is moving more to an entropic state now.
No.
Because, yeah, they're moving to entropic state now because it's looking more viable.
What's entropic
Weird
mean?
that. Just they're trying to keep with the laws of thermodynamics. In other words, it has tendencies to move to a certain area with the arrow of time.
Oh, entropy. Yeah. Okay, gotcha.
Mm-hmm.
Something you have to keep in mind when you're unifying the field theories, it does not mean we're trying to prove that gravity and electrostatics are one and the same. That's not what unifying the forces mean.
You sure?
Yes, I'm sure.
It clearly states that they are one of the same.
No, they aren't.
How do you
Why
know,
do you-
George?
That's not what was claimed.
Are you sure?
Yes, I'm sure.
It's even
How do
claimed
you
as a
know,
magnetic core.
Nobody's claimed that gravity and electromagnetism are one and the same.
They've
It
always
says
claimed
they're
it.
just different manifestations, but of the same basic force.
That's what
Right.
the unifying field theory means,
But
is
they
that
haven't unified it
we
yet.
have the symmetry was broken at one point, and the single force that originated broke into four forces: the strong nuclear, the weak nuclear, electromagnetism, and gravity. And what we're trying to do is show how these all came before symmetry from this one force.
Why?
But you
It
can't.
doesn't mean that
Yeah,
they're
but you
the
see-
same. Electromagnetism and the strong and weak nuclear forces are not one and the same. And neither is gravity. There's nothing in Maxwell's equation that suggests that
So,
gravity
George,
is related to it, and neither is there anything in the gravitational theory in the gravitational field equations that suggests that they are electric or magnetic in nature.
Yes, because it doesn't exist.
So,
No.
George, the only way to provide this understanding is through a set of equations, right, George?
It certainly helps us.
So it's just a set of equations.
No,
right,
it's not just a set of equations. Maxwell's equations, the four equations that relate electricity and magnetism, is used constantly. Those equations paired with appropriate boundary conditions explain all of electronics and electricity.
Okay, so that would be an applied theory, George, rather than a theoretical.
Well, we use the theoretical equations and apply them.
Right. But you can demonstrate that, right, George? And the other one, the only way you can demonstrate it is with equations, right, George?
No.
Okay, what demonstration can we do?
The general.
What demonstration do you have in mind that we can do?
Einstein's general relativity equations have been verified
What
through.
demonstration can we do, George? That's it. Just what demonstration you and I can do. That's all I'm asking. Don't run off into the woods, please. Just the demonstration.
Demonstration of what? the field equations?
The theory exists or consists of a set of equations, right? That demonstrate gravity, electricity, and magnetism, right? But can you demonstrate that? Or is it just equations that demonstrate that?
I have no idea what you're asking.
Do you have a practical demonstration that can show these theories?
Yes, I mean, the four Maxwell's equations can be shown. I mean, if you want to look at, say, Faraday's equation, that the divergence, the curl of the electric field is equal to minus the time rate of change of the magnetic field.
George.
That's called
That's not what I'm asking,
That's
George.
not what I'm asking,
I'm
George.
trying to tell you, if you would just listen.
Demonstration,
that is
George.
electrical induction. All you have to do is take a changing magnetic field, put a circular conducting path, like take a ring of wire, and insert it in the changing magnetic field. You can hook a voltmeter up to it and see that an electric field is induced in it, as predicted by the field equation.
But also gravity. Can you demonstrate all of it into one, or do you can only write it down in mathematical numbers?
Again, I have no idea what you're asking. George. What do you mean? Can I show it all in one? There are four equations that we call Maxwell's equations, and they each treat a different aspect of the electromagnetic phenomena.
So they're separate then.
What do you get when you put a 10-foot copper rod in the ground with some conductive wire attached to it and attached to another conductor?
What do you mean to another conductor?
Like a lead or zinc or something like that. What do you get if you have a couple wires?
So you're going to drive a copper rod into the ground, into the earth. You're going to attach a wire to it, and on the other end of the wire, what are you going to do?
On the other end of the wire, you're going to have lead, and then you're going to have another wire with another hunk of lead going into the ground. What can we get out of that?
Nothing. They're at the same potential.
Okay. What if they're different materials or different sizes?
Makes no difference. They're at the same.
Yeah, I'm gonna really show you an earth battery. When there's 100 videos on YouTube already on how to put a coil of wire in the ground. It works better with a rod in the ground. Okay, and a couple of them. Okay, if you line them up with the Earth's magnetic field, you get a little more current. And no, it's not a giant amount of energy. It's not a giant amount of energy, but it's enough to make enough to make a little magnet out of if you wanted to.
That's impossible, Brian, because the Earth's magnetic field is static. You cannot induce a current from a static magnetic field.
No, I just said that you get a little more juice. It's a demonstration.
No, you don't.
You get a little more juice if you line them up. Instead of lining them up like east to west, if you line them up north to south, you get a little more juice out of them.
No, you don't. Again, the Earth.
Yeah, I know. It's not in your textbooks. You wouldn't know nothing about it, man.
I do know.
There's an up-and-coming generation who's figured all this shit out, bro.
The Earth's magnetic field is a static field. It doesn't matter how you orient.
I'm not saying it's drying off the Earth's magnetic field. Did I say it's drying off the Earth's magnetic field?
Brian, you're interrupting me again.
George, did I say it's drying off the Earth's magnetic field? Did I say that?
Yes, you did.
No, I said if you line it up parallel with the Earth's magnetic field, you get a little more current.
And I'm saying
measurable by a voltmeter.
And I'm saying that's wrong. That can't happen because the Earth's magnetic field is static. It cannot affect.
I'm not saying it's due to the Earth's magnetic field. I'm just saying if you align it that way, you get more current. It's demonstratable. It's it's replicated over and over in YouTube videos, over and over, bro.
It's not demonstratable. It's wrong. You cannot change the current.
All their voltmeters are broke, George. All their voltmeters are broke.
Brian, quit interrupting. You cannot change the current flow in the wire.
Your fingers in your ear going, la 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 la. like you got your fingers in your ear, bro. Like I'm just telling you something for no reason. This is what I do, bro. This is the shit I do. I tinker.
Brian, you cannot change the flow of current in a wire by aligning it differently within the Earth's magnetic field. That will not have any effect whatsoever on the current flow in a wire.
See, if you were really into science, you would say, you know, it ain't the Earth's magnetic field, but yeah, something. Maybe it's something else. You know, maybe it's moisture on the side of the property, and it just happened to work that way when these people did this. Or you think of another way it might have happened, of where north-south alignment got more charge. But the fact of the matter is, let me talk. I'll let you talk. The fact of the matter is if you line them up north to south, you get a little more current.
I doubt it. There's something else going on that hasn't been taken into account.
Dude, you can doubt it all you want, bro. You're wrong, okay? You're wrong.
You're implying that orientation with the Earth's magnetic field has an effect. That's what you started with. And I'm telling you.
That's exactly right. Look up any, if you don't, I mean, I could do it myself again, but I'm not sure I posted the video, but look up Earth battery, and you'll see plenty of people demonstrating it. And it's easily demonstratable. It's nothing that hard, bro.
I'm not going to go hunting for this.
Maybe this is why, George. Maybe this is why they haven't. Maybe this is why they haven't figured out the equations yet, because they deny.
Maybe you provide me with a link to this so-called Earth battery you're talking about. I can look at it, but I'm not going to go hunting for this stuff.
George,
yeah,
do you know
we'll never figure out the equations. It'll be up to the next generation to figure shit out because you got your head stuck in the fucking sand. Excuse my language.
George, do you know what a telluric current is?
A what current?
Telluric current.
Spell it.
Telluric.
No.
So it's a current that runs under the ground that people can tap into.
That's bullshit.
They're resulting from both natural causes and human activity.
No. There's no current flow that runs in the Earth that you can tap into.
Okay, if you say so, buddy.
I do say so. If there was, we'd be using it today.
Telluric current, Wikipedia. Telluric current is an electric current which moves underground or through the sea. It's also referred to as earth current.
Just like if there was, an alternate to, let's say, fossil fuels, we would be using that instead of fossil fuels today, right? If there was literally anything else in the whole world we could use, we would definitely switch to that right away and no one would have a problem with it, right?
Well, yeah.
There's nothing wrong with oil.
Of demonstrations of the Earth batteries, and when you line them up north-south for some reason, maybe it ain't the Earth's magnetic field, but it's that direction that with the compass that you get a little more trickle, you get a little more charge out of them, and there's dozens. Okay, that's just one.
I think you were trying to say something. Your mic was really, really low.
Yeah. One other thing, real quick, Data.
Germany, because I have another formula to try.
George, do you have something playing in the background, George? I think it's coming through your mic.
What?
I think you have a video playing. I think it's coming through your mic or something.
No.
That is, you're listening to me, George. I think I can hear my voice. I think.
Yeah, I can too. It sounds like a muffled flutter data on the plane. But one last thing to George is, George, man, you really gotta. Instead of getting so defensive, I mean, I need to back down a little bit. Sorry for being rude, dude. Really, no. But I just want to say, man, is people are just trying different things, and a lot of this stuff is maybe not even what we think it is. Maybe there's totally different explanations for some of these results we're getting. But you can't just shut out. You can't just shut out, bro. You're shutting out a reality, man, and of certain things, and you could put your good head into helping us figure out why some of these things are happening that have not currently been explained. There will be new discoveries, George. That line, man. We need people like you to help us line up some of this stuff, man, instead of just denying it, man, shooting it down. That's it.
I did have a question, and it's a pretty basic question, but something I've always wondered about. How is it that we've ruled out the idea that the Earth's magnetic field is impacting the Cavendish experiment, or what are those called? The pendulums, or even that difference in weight at different altitudes or latitudes? How have we ruled that out as a cause?
It could be the Casimir. It could be the Casimir effect.
Yeah, but how have we ruled out the Earth's magnetic field? Because we do know that obviously
Earth's magnetic field first,
does have
Brandon.
It does have a force.
You rule out the supposition first.
Huh?
You rule out the supposition first. What's the supposition in any of these observations? What's the first thing you're trying to find out? And then what are you doing? You're observing something that you have no idea that you're observing what the cause is, but you have a supposition what the cause is. So why don't you rule out the supposition first, or the presupposition, let's say? Why don't you do that before you look at something that's moving and oscillating? Why don't you address the presupposition?
What is the presupposition?
You're creating a man-made thing that's oscillating, and therefore you're trying to say this oscillating is a cause of this. You have a presupposition.
Wow.
When it's not actually occurring. Where do you see it?
Where do you see it? Well, you see it.
Where do you see the Cavendish? Where do you see that?
Are you going to make me defend the Cavendish experiment?
Yeah.
Sure. Where do we see it? Where do we see the Cavendish experiment in reality?
Well, I mean, it's not a naturally observed phenomenon. I understand that.
We have to conjure the reality then, right?
What?
You have to set it up. Yeah.
You have to conjure the reality. You have to think of it and then put it in that reality, and then deduce from that reality that you conjured it for.
Yeah. So,
anyways, I got an answer to what you were saying, Brandon.
Okay.
Black magic.
Okay.
That's all it is.
All it is. Yeah, that's exactly it. So Blue's a black magic. What, warlock? He must be, because he made a Cavendish tapping into
Blue
the
Marble Warlock.
magic of the Earth.
Conjuring it up, man. You conjured up the idea, conjured up the reasoning, you reified the reasoning. If anybody here thinks they can determine the density of Earth with two balls oscillating, they need to try the simple pendulum experiment where you can calculate the oscillation to cycles and know there is no constant to it. You may get close variables here and there, but there's no constant rate. And then you have to realize you're conjuring the reason. The pendulum was just made for time. It wasn't made to calculate the density of Earth.
Oh, of course.
The rate of gravity. It was originally used to map out the heavens for time sequence. That's it. And then all these reifications came through conjuring the concept of the man-made construct.
Yeah, these guys be extrapolating shit crazy. They're getting the circumference of Earth from sticks and shadows. They're getting the density of Earth from fucking this cavern. Like it's ridiculous.
That's one of the most ridiculous ones. Is trying to say you know how much the Earth weighs because of the Cavendish experiment. I think that's just utter lunacy.
Hey, Brandon, do you know that they calculate water in rocks? Do you know that they have a measurement for the rock density?
There is lots of water hydration in rocks, so
that's right.
A lot of the rocks would not be solid without water, so leave water out of it.
No, but they don't think of water as part of the density of any of these materials. Why would it matter? They don't think of it.
It absolutely is.
Yeah, but they don't think of it. It's all good.
Hey, how about if Blue was to change those lead bulbs with two watermelons?
No, he needs to use some helium balloons. Show us gas attracting gas. Let's get a watermelon and a helium balloon on there.
You think they would attract?
Jeremy.
I want to get a gyroscope on one end and a fucking helium balloon on the other end.
Jeremy, I can
Don't forget the
calculate the
watermelon. Come on.
I can calculate the oscillation of a straight bar hanging from a ceiling.
Bro, I don't even know what that word means.
This week, hey, Dad,
Oscillate?
this week is going to be math week for you. You've read a little bit about math this weekend, and now this whole week we're going to have to hear about equations and all this shit from you. God damn.
So I got two bowling balls. If I were to hang them from my garage, would they attract each other eventually?
Why do you think your testicles are touching? SD.
Yeah, exactly.
This is la la la.
Cavendish.
Ridiculous.
Natural observed phenomena. Testicles.
It's the most bullshit experiment, pseudo experiment I've ever heard.
Who's got the echo?
That's
The
me,
only
all right.
the only thing that I see the practicality is what Coulomb did, which is applying positive negative traction forces, showing that you can repel and attract things based on electricity.
I wish you could play the
solve
first
that
2 minutes of my gravity video, man, of Blue Marble or gravity demonstrated. Mass attraction, gravity, proof of gravity demonstrated. That's Blue saying that that mass repels mass, and in the first 2 minutes of it, dude, it's hilarious.
Wasn't he saying that the lacquer
that's
he
some
painted
balls.
it with is affecting the charge? Wasn't he saying some stupidities like
Saying
that?
that the lacquer,
No, he
dude,
was not.
you should hear it's a joke, dude. It's a joke. All the excuses he come up with, they're all electrostatic shit, and that's all the changes he made. We're all
Does
freaking
anybody-
electrostatic.
Does anybody here think that man
What do you
can
want to
actually
change?
calculate the density of Earth? Do you
That's
really,
ridiculous. We know that's ridiculous.
Bro, we
We're
can
just
get the
making fun
density.
of Blue.
We can get the density of Earth from
Round-
sticks and shadows.
So
How you
why
like
don't we
that?
I'll
just
tell you
approach
exactly
it?
how it happened. Y'all want to hear how it happened? That's funny, Jeremy. But they come up with the number. It took them a while. They come up with the number that they needed to work their model, and then they found a way to demonstrate. They seen Coulomb's apparatus in his demonstration and adjusted it just right. It took them forever to get the copper foil and the grounding and all this shit just right. They got it where they could show repulsion with these lead balls if they do it just right. But they got it just right and set up in an exact perfect way that has to be done to a fucking T to show the oscillation, to get the calculation.
Isn't that how all technology is? Isn't that how all technology is? You have to work out the bugs, and you get it just right so it works the way you want it to work. What do you
The way you want
about?
it to
That's
work. You said the
technology.
key
That's
word,
what you do
Tony. The way you want it
Not
to
if you're
work.
hijacking a force, though. Not if you're
Yeah, but if
prove some fantasy, you get stuck in a paradigm for 104 years.
Hey Brian, do that thing with your
Does
mic
To-
that you did the other night, will you?
Told him on Jose.
yeah, do that thing you did to the mic the other night and turn it off.
Tony,
Brandon, we were
you know
talking
that I
about
can hang
copper
a-
plates on Jose.
you know
I
that
hope that's
I can
better,
hang
but
a-
somebody else is echoing there, Brian. I think somebody else's mic is echoing, man, in my
That's
opinion. But my
Tony.
mic should be better.
Tony's fucking potato. He's needs to replace.
Yeah.
Tony,
We were talking
if
about-
I hung
Shut up.
a bar on a string and it oscillated, are you telling me all I had to do is put two other balls on the end of that stick, and I can determine the density based on its oscillation?
If you
What
think it sticks,
supposition would I need to start with?
Jesus, I'm not talking about your suppositions right now, okay?
Well, you have to have a supposition.
Supposition. That's great, man. Okay, if you want to start at the beginning of everything, you're always like,
Tony, your mic is
Everything
hot
that
trash,
start
bro.
from
I have a supposition that you bought your mic at the fucking Dollar
Yeah.
General.
I fixed your mic. Any other natural
Wait.
phenomenon, there's millions of different ways to prove it. Maybe even the ones we can't isolate exactly how they happen. Maybe it took a few things, but they're all easily demonstrated. But you got this one that can't be demonstrated, and your whole model's dependent on it.
Hold on, we
Right,
gotta get this
decibel
straight.
level-
We gotta get this straight.
Hold on.
Tony,
Hold on,
Tony
real
B,
quick.
did you get your mic at Dollar General?
Yeah.
Yes. Yeah. Okay.
yes.
I also want to say,
supposition
Brian,
that he's
hold
using
on.
his mic as a suppository.
Hold on,
It is
I
a
also want
supposition
to say that
suppository.
Brian's microphone decibel level is a natural observed phenomena.
It does
Hey,
sound
guys,
like somebody's talking out their ass.
Hey guys, when they want to show us gravity, what do? They draw a
Sorry
pen,
about that. I
right?
hope this is better, man.
Fine,
Oh,
Brian.
that's way better. We were talking about copper plates on Jose's, and I said Brian needs to put a copper plate between his mouth and the microphone.
So why don't we address the supposition in Blue's experiment next time he's by or Bob's by, just to get some clarity? Because you can talk about the oscillation pattern, the formula all day long and what it means. Why don't you talk about the supposition before?
Does that sound better?
Say something else. Sing the ABC song for us.
ABC. Yo, check.
It might be worse.
Yeah.
It might be worse. I don't even know at this point. I didn't think it could get worse, but I think you just made it worse.
It's like a CB radio attached to a 1980s cell phone over a loudspeaker.
And we're listening to it after somebody recorded it
I
on a
want to say
Fisher
this
Price
too, with a
tape
better
cassette
mind.
player.
Anybody who wants to hear Blue Marble Science saying that that mass repels mass, that he's even joking, but you could hear the whole video is funny, especially when you see the end. But in the beginning, the first couple minutes, he says mass. He proved that mass repels mass, and it's a flat Earth test. I posted it in the general here in Discord.
Okay.
So anybody
Brian, are you like lounging on your couch or something? This is the first time I've heard you where you sound like you're not climbing the steps of the Empire State Building.
Yeah, I'm making a concerted effort to sound a little bit better here.
Thank you, Brian. You're doing a good job. We're giving you a lot of shit. But... All right, I'm bringing your video up. Let me see. It's on Flat Earth Tests? I don't see it, Brian. You said you put the link out there, though?
Hey, Brandon, if you're interested, you should read this article of how a pilot saved 72 passengers because all of his instruments went down in a plane and he used a glass of water to land.
Oh, that's pretty cool.
What's that prove, Data?
Well, why would the pilot? Why would the what knowledge?
An artificial horizon.
What knowledge would the pilot have beforehand to think of even using water? What would he have to think water does to be a reliable source
keeps
to
its
land
own
a plane?
level? Yeah,
Could it be that water is level and horizontal?
Could
that be it?
To be fair, the globe Earth argument on that would be like it just needs to be level. Even if it's curving, it would serve its purpose for landing the plane.
Tell him, talk to him.
So it served as an artificial horizon. Wow.
When you ask them, unfortunately, what prior knowledge do you have to understand that water creates or what water does? They have a hard time answering that because indeed it creates a horizontal path.
That's not what they
Now they'll just say it creates level.
It's a horizontal path, right? Which matches the horizon.
No, they'll disagree with that.
Well, it doesn't matter if they disagree. I have a practical example where a pilot uses the water to land a plane. And
yeah, but that doesn't show us if it's horizontal or level, slightly curving.
There's only one reason. There's only one reason why he would use it.
Because it's level. He's trying to keep the plane level.
He's trying to land the plane, so he doesn't want to dip too far.
It doesn't tell us if it's flat or slightly curved.
It tells you that you live on a horizontal plane. That's why he would use water. Because water.
It doesn't tell you that.
Water.
Confirmation
water,
bias.
Water creates. Water creates. I don't have a confirmation bias. I'm telling you what he used it for. He used it for that reason. Because equal points of elevation creates a horizontal path. The gyro creates a horizontal path in 3D space. It has nothing to do with the shape of the Earth. Water creates a horizontal path to equal points of elevation. It has nothing to do with the shape of the Earth. That's why it's horizontal.
Hey, but this thing with the cup of water.
Everything else is your supposition of why water does what it does. I'm saying, observably, water creates an equal point in elevation, which creates a horizontal. Everything after that point is your defense of your ball.
An equal pointed elevation on a sphere still would be level. It would just be curved. Like, I don't know how.
Okay. So you just answered the question then. Equal points of elevation on your ball model is curved. So he.
What do you mean your ball?
You guys are fucking
your
crazy
ball
today.
model.
It's you're a glober, right? So.
No, you fucking idiot.
Your
percentage, big time.
Yeah, percentage is a glober.
Big time.
Yeah, he's a glober, 100%.
Big time.
All right, you got me.
Got you, dude. Equal points of elevation is only possible on a plane, not a ball Earth.
afternoon.
I mean, I believe
heard
you when you
level,
say
so I
that.
had to
I
come
also,
in.
It's observable, repeatable, and testable. What do you mean? You don't have to believe me. Just believe what water does. Everything else after that is your supposition.
yeah, but how do we know it's?
Observe reality. Include what you want. The reality is water, 2 points, equal elevation, horizontal.
Do you have any measurements of this
measurements of water, equal points of elevation?
being horizontal? The horizontal part, I'm very
So
interested.
why
in.
would a pilot use it? What knowledge would he have to have before he landed a plane?
Oh, we proved it, Brian. The glass of water on the plane dashboard. Shut it down. It's all over.
So
back it up, folks.
So there you go. That's the attitude. Those are ballers speaking right
now. Data, what the fuck, man?
Come on, man. These aren't ballers pretending to be flat earthers. Give me a fucking.
Bro, we gotta
Use your
stop
fucking brain, man.
We gotta stop getting drunk before the show, guys.
2
please.
equal points of elevation is
He's right though. Hey, Data's right about that one thing, man. They act like everything is just solid proof. Like that is how they act. Like it's proof. It's a globe. Look, it can't be anything else. It's because of this. I mean, that is their attitude, man. They won't budge on nothing.
Well, yeah.
So are you guys saying that water curves? Am I hearing correctly here? Is somebody
That's what they
arguing
just said.
that water curves
No.
here?
Jesus, Data. See what you started. Listen, we're just
Hey
saying
man,
that.
you gotta call a baller out when he's a baller, right? You're acting like
This-
baller, so you're gonna get
Well,
called
that
out for
sounds
it.
like a baller to me. I hate
No.
to say that, man, but are you guys playing or what?
No,
They are
see,
ballers.
so he said something stupid, and we're just
Jeremy's a
correcting
baller,
him.
and
He
Patricia's
said,
a
Okay, all
baller.
right.
When
"Hold
I'm
on."
just-
Cup of
This is
water.
what happened, Essie. He said, a pilot using a cup to use it as a
using
level
a cup?
kind of thing to know how to land.
Using a cup, or is he
means
using water in a
a
cup?
cup of water. Sorry, using water as like level to know how to land a plane
Not how
means
to land a
that
plane.
that
in an-
level
in an-
is therefore straight, which is not necessarily the case. It's not
I'm
proof
sorry?
that it's straight. It could be a
I'm
curved
sorry?
Earth, like hypothetically.
So hold on. I can demonstrate my claim with an article and with practical demonstration. Can you do the same with yours?
Dude, it's not my claim. I'm just saying that your claim that the
Again,
cup of water
I
is
can
automatically
back it
flat
up.
is
I can
wrong.
back it up with a practical demonstration via this emergency landing.
So back it up, man.
Okay, so it already has been. Are you okay with that?
So the pilot landed using a level cup of water, and therefore the level is automatically horizontal.
What knowledge would you have to grab a cup of water to land a plane? What knowledge for
That water is level. That doesn't mean
There
it's
you go.
curved versus flat. You haven't figured that out.
So
Are you
it's
familiar with
level.
the water level? A tool
sakes,
called
man.
the water level?
You're a Glober percentage. Nice try.
And you're an idiot for not getting this.
Are you familiar
not getting
with
what
the
practical
tool called the
demonstration
water
that
level?
water with 2 equal points.
That a cup
will
of
create a
water does
horizontal-
not mean automatically that level, while that water, that
Okay.
while
Are you
level is
listening?
flat.
Are
you
you
have to understand
listening?
that.
What knowledge
Am I muted?
have to have beforehand?
No, I hear you.
What knowledge would you have to have beforehand?
Can I ask both these guys
That
that
water
are talking right
creates
now?
a level
They're
path
familiar with the water level.
between 2 equal points of elevation.
Of course, bro. Water's level. There's no questioning that.
There you go. So there's
He's
nothing else
assuming that
guarding
water,
the ball.
that level water is
Nothing.
flat.
I'm talking about the tool
level.
called a water level. The tool called a water level.
Yeah, we know what it is, bro.
You've been
Does that
sucking on
tool
Lola
establish
Dick too
a
much,
horizontal plane of reference?
Yes.
Then
One
it's a
more
straight
question.
line.
Can level water curve?
That's the claim.
According
That's
to
one of
their
the big
model-
claims.
Yeah, but we
Forget
don't
their
have
model.
any.
According
Okay,
to reality.
I'm not interested in what they claim. Again, it's based on a supposition.
Percentage.
I'm using it
Hold
as a
on, Dada,
practical
hold on, hold on.
example,
Percentage.
which means I
can
don't
level
have a
water
supposition.
curve
I just
in
have
reality.
observed reality.
Hold on,
What?
Dada. Percentage. Water curve in reality.
What was the beginning of that?
Can level water curve in reality.
Dude, I believe that level is straight. But
Okay.
it's,
Done,
it's,
all right.
hard, it's different to
You know who
actually,
percentage is.
demonstrate it, right? And he's
No,
claiming that
it's
they
not.
demonstrated
No,
It's not
not.
hard to
It's not,
demonstrate
bro.
it.
It's not.
Not if
They
you know
build
what a water
buildings
level
with
is.
it. The base of the
All we
pyramid
got to do is
was built with
all we
it.
got to do is we know the base of the pyramid. All you got to do is make a horizontal plane and compare some water to it.
So you're ignoring reality and backing up the ball. Nice to know you
We're not
Globers are on
ignoring
this
nothing.
channel.
I'm just saying, do you got a measurement for it, or you got one, Rob?
Measurement for horizontal water?
Rob, you got one?
It's
Well,
hilarious though,
knowledge.
because you
Yeah.
what's called play devil's advocate for a second to keep these flat earthers sharp, to keep us on our game, so we won't say stupid shit, and automatically you're a globe earther for saying
Can
it.
I point something out, guys? This, if you want to think about an analogous argument,
I'm not calling
I
anybody a
think a good
globehead.
one would be
I didn't call anybody a glober either. Just
Except
wanted some clarity.
Babs Spaceball. Yeah, I'll definitely call him a globehead.
or container. Can you guys
Yeah.
hear me?
Say it again, Bob.
The argument you guys are having, I think, is analogous to the gas pressure without a container thing, okay? We can say, logically, there must be a container for there to be gas pressure, but we cannot show you a measurement of that container. Saying it is in existence because it must be due to logic is not the same as measuring it itself.
Well, I disagree with you there too, bro.
No, I agree with.
I would say
He's on
if
your
it
side.
follows, yeah,
Taking your
but I would
side.
disagree with him by saying, if it follows the same natural laws up there in the skies, which we don't know,
right?
Then yes, it would necessitate a container. But if it has a different set of laws,
but that's
different
not
set
the
of
same
rules,
as
then it
measuring a
doesn't
container.
necessarily.
That's not the same as measuring one.
I know, but you can't say automatically that there has to be a container when we don't know the laws of nature of the heavens.
You guys are agreeing.
What's up there.
I agree with
You're
that.
agreeing he's agreeing with you.
All right, cool.
What?
I was just trying to provide an analogous argument for you guys to understand that, like, saying that we can agree that the water is what it is, okay? Flat, level, horizontal. We can agree on that and still understand that we can't necessarily demonstrate it in the way that they want us to, which may or may not be ridiculous depending on where you're standing, okay?
Unless you use the
that's
water
not an
level.
argument saying suddenly that the water is curved or that it's not level or that it's not flat. That's just accepting that it is a thing we understand to be true while saying we can't show you the way you want us to show you.
Yeah, 100%.
So I have a practical demonstration.
But
because
to the other guy that keeps on...
under the knowledge of what water does when it's contained, which is create a horizontal, the pilot saved 72 passengers. So I would say that's a pretty good example of relying on physics of water and what it's observed to do in reality without any imaginary thoughts after.
You
guys want to have imaginary thoughts after. That's why you're discussing Cavendish, because it's imaginary.
Bro, you and the other guy that keeps on saying water level. Water does not, like, you can't show it, you can't demonstrate it as showing a horizontal. You haven't done that.
Sure you can.
Show us the measurement.
Can I ask you a question?
Show us the measurement.
There's no measurement for it. Does it?
Let me ask you a question then. Have you ever used a water level?
Yes, I know what a water level does, and a glober will tell you.
Does it make a straight line?
Find the level of the water, which is curved.
When does it stop making a straight line?
They'll claim it doesn't make a straight line. We don't have measurements showing it makes a straight line.
As in following the horizontal.
It's not a measurement. It just does it.
You can make a straight line from the tip of each water level, but they're saying
Can
if you make a horizontal
straight line with water, people? Yes or no?
I believe you can, but the claim is
or flat earther. We have no measurements.
In reality,
it's
can
like
you
you
make
guys
a
don't
straight
know the
line with
claim.
water?
Jeez, you guys need to talk to more globers. Hop into debate
I
flat
don't
earther
need
more.
to
You
talk
guys
to
will
more
get
globers.
eaten alive.
Globers live in La La Land. Can you make a straight line with water?
I believe you can. Can we demonstrate that? Can we claim that this water level is always flat and not what's called, and actually back it up? Not yet.
Okay.
Yes, we can.
They make giant mirrors by
liquid
liquid
water
mercury
line?
and water. That's how they make giant mirrors.
I've heard of a
perfectly
water
flat.
line.
But yeah, over distance they say it's curving, and I say it's not. I say at 5 or 3 miles, it's not dropping no 20 feet or 6 miles. 27
and
feet.
as of right,
but
as of
far
right,
as proving it, I can't go out and prove it. But they act like they are certainly positive that it's curving, and so I don't see nothing wrong with acting certainly positive that it's flat.
You go ahead.
Now, there's no definitive evidence to say that it is or isn't curving. If somebody has some definitive evidence, let's fucking see it.
It's used every day in construction.
Do you have anything definitive or other than this glass of water on the dashboard of the airplane?
So it saved 72
Anyone?
people under the pretense of what? That it creates what kind of path?
A level. A fucking level.
Horizontal.
Jeez Louise.
Level. 2 equal points of level. 2 equal points of elevation is level.
You're just like a glober, man.
Data, how would
You're
it behave
as,
differently
like,
if the
zealous
Earth was a
without
globe, this glass of
evidence
water?
as a glober?
What would be the difference on both models for this glass of water? How would it behave differently on a globe?
Now you're begging the question, why do we have to have a ball?
Because you're trying to use it to falsify a model. So I'm asking you, how did you falsify it with this glass of water?
Because the intention is a straight line in 3D space.
No.
Yes.
No,
That's
the
the
intention is level.
The intention is it's a straight line in 3D space.
How big is the
purpose
plot
of
of
a
land
gyro.
you think they're going to land on?
That's the
Hey,
point
wait a
of
minute.
the
When we see a
gyro.
It's
horizon,
local
like
level.
when we
That's
can
the
see 5 or
intention.
6 miles
That's
south,
That's the
use.
point of the horizon, or it's part of the
if
point
we
of the
see a,
gyro.
hey, hold on, y'all. If we see a horizon and it's 5 to 6 miles from right to left and it's completely flat and not dropping on each side, ain't that proof, kind of?
Yeah, but it's not a measurement. That's empiric
So-
evidence. That's
so
why I'm a flat earther.
when
Because the
you
horizon
measure
is
things-
horizontal.
When you measure things and you need a straight line, what would you use?
Dude, like, who are you
I
trying
would
to
use,
convince
I would
right
use the
now?
double riding method that Bev talked to me about on Jose.
So you have a supposition on what it does, right? There's a knowledge beforehand.
Why did you even
of
ask
why
that
you're
question?
using it.
Did you hear what I
Well,
said?
you have knowledge beforehand. That knowledge implies what? A straight path. You don't grab
No.
something
What?
that develops a curved path to make a straight line.
On the globe Earth model, on a local, like, setting, landing
On
a
a local
plane,
setting.
a short
So what is it?
distance,
Are we little
and
ants?
the curve is going to be
Ball?
almost straight. It's going to be
Are
almost
we-
flat. So you haven't
are
shown
we a-
any sort
Are
of
we a little ant
you
on a
haven't
big
shown any
ball?
sort of differentiation between the models with this cup of water.
There's a
Euclidean
subtlety that seems to be
geometry
missed here.
would match.
Let me clarify
Euclidean
something.
geometry would match.
Let me try to clarify something because we're arguing past each other. A water level, if you draw a line between two ends of water level, yes, it makes a straight line. No one questions that. It makes a straight line all the time, every single time if you connect the two ends of a water level.
Is that
what
because
is
of our
being
knowledge of
questioned
what it
is
does?
whether that straight line is parallel to the surface of the Earth.
So in flying a plane, the plane doesn't care about the topography of the Earth. All it cares about is creating a straight path in 3D space.
Okay.
Right? So if you're landing a plane, you're going to want to level your plane out in 3D space. When you look at water, it also provides us a straight line in 3D space in construction. So what else do you want to infer after this point?
It creates a straight line in space. We're interested
That's right.
around here with the
That's
shape
right.
of the ground.
You
ground.
just proved it. It proves a straight line in space. So
Yeah.
if the
Between
straight line
two
in
ends
space,
of a water level, two ends of a water level, 2
listen,
points.
if you can create 2 equal points of elevation on Earth, which you can, and in between them create a horizontal path, a straight line, which you can, then again, where is this curvy bending line?
Listen to me. Okay. Listen to me very carefully. The line that is you created by connecting those two ends of the water level is whether or not it is parallel to the ground is in question. You haven't said anything about the points in between the two ends of the water level, their relationship to the surface of the Earth, just because you've connected them. All you've done is create a straight line.
The purpose of the water is to create
Brandon,
a
I
straight
disagree.
line. Same with the gyro compass. It's to create a straight line.
I'd say the parallelism of the line isn't an issue. It's going to be parallel.
We agree that we can create a straight line, right?
We all agree that you can create a straight line.
Awesome. So at what point does it have to curve to be a ball?
No, we don't. Well, I mean, like, that's not the globe Earth conception of it.
But that line, hold on, percentage. Just the line you're creating. When you connect two points, it's always a straight line.
Hey, I got an idea
That's
for a
all
test,
you're
y'all.
doing with the water levels, connecting 2 points.
I got an idea for a
and they're
test.
at the
Y'all
same
just put me on an
elevation.
idea, y'all.
The question is
Let me
whether
throw
that
this out there.
line is the same elevation all on at every point along that line to the surface of the Earth.
You're right.
I agree with that. But listen, Brandon, how about this for a test? Okay. So when we do the long distance lasers, they say the water is refracting. Okay. But so if we just take a shorter distance, like say of 1 mile or maybe 2 miles, let's say 2 miles, and we get a laser, it should be easily strong enough to go 2 miles, right? And we just shine from one point of the water level to the next. We'll all agree that's a straight line. And then we measure it in the middle instead of trying to go these super long distances, which to me easily proves that the
What
water's
was
level.
refraction for using a laser?
Right, they cry
And my bad,
refraction. But
Brandon,
if we're going to point to
I
next, though,
misunderstood you when you were
are they
saying
going to
before.
say that if and we show in the middle that it's up like 2 foot, at the end it's up 2 foot? I mean, at each end it's up 2 foot. And if it's 2 foot in the middle, are they going to say that it's refracting and then refracting back down or something?
Yeah, they just cry refraction whenever it's something like, to do with light.
They're afraid of the straight
There've
line.
been so many laser tests.
They're
We're
afraid
on
of the
to
straight
something, man.
line. It disproves
Hey,
their
if we
ball.
get them to acknowledge, though, if we get them to acknowledge that between the two water levels is a straight line, then the test is in this. They all don't even admit that. Believe me. Some of them, it's hard. I mean, we need to figure out the ones that are at least honest enough to admit with 1 mile curving down or a Sagittarius chord in the middle, and come up with a test, man. That was the best talks we had, trying to think of ideas on how to prove this shit, man.
Yeah, what happened to White Sword?
He's still out there. I haven't gotten an update from him
the Pontchartrain
in a
Bridge,
little,
man. We should
little while.
be able to prove it.
He's here on a regular basis. He just doesn't join the show that much. But yeah, Whites, we'd love to have an update on what you got going on. Even if you hadn't made that much progress, we'd still love to hear what's happening.
Yeah, Travis started the GoFundMe, man,
Yeah.
for me for that fishing line, and I got up to 125. Brandon pitched in, and Travis pitched in, and a couple of people I know pitched in, and since then it's just stagnant. It's like nobody even gives a shit, man. But if I'm gonna either wind up doing it, and or either giving y'all his money back, or either doing it and giving y'all a few bucks back. But if everybody pitches just a couple bucks, man, I'd have the money I needed to do the shit. But eventually I'm gonna do it regardless, But it seems like not as many people are as interested as we think in this, in proving, in what we can prove or demonstrations, I don't know.
I have no clue what you're talking about. Maybe you've talked about it before when I wasn't here.
We spent a lot of time trying to come up with an experiment. Jeremy's talked about it a lot in Gems. And so
just for the hell of it, I'm gonna post this GoFundMe. I'm gonna post this GoFundMe for the hell of it.
Brian
Like,
is doing some stuff with fishing line. We don't have
Brian. If you don't dig a trench, get some.
We're trying.
Brian, if you don't dig a trench, get some calm water, get a winch and a scale, and the right buoyancy on the fish. It's just, you can't do it in the ocean with tides. You got barnacles growing, line and.
I found a lake, man.
There's fish and frogs. Great
if
white
I get the
sharks
money
and
up,
shit.
or when I get the money up, I'm gonna go. I got a 1 mile and a 2.5 mile. I'm gonna do 2.5 miles and 1 mile at the same time, and show the results. I found a lake almost 3 miles.
Nice.
I'm gonna post a GoFundMe in general.
All right. What was I gonna say? I never did get an answer to my question on. Is it possible that the magnetic field of the Earth is impacting some of these things? How was that ruled out? Does anybody know what the actual answer is?
Impact on what?
Cavendish and
no
pendulums.
Foucault's.
No.
Foucault's, yeah.
If they're not magnetic, then it won't affect them at all. So if you haven't had lead balls, for instance,
But lead is affected by magnetic fields. Though.
Yeah.
So it's
really.
brass and any other material.
Everything
that you
is.
can think
Can
of.
you just rule out? Tell me how it was ruled out. How it was isolated and taken out of the.
Well, the
contention as a
balls
variable.
inside, for instance, Blue Marble's Cavendish experiment. He's got it's lined with copper. Acts like a Faraday cage. And he's also grounded all the balls.
So does copper block the Earth's magnetic field?
No, it did.
It does to some degree. It doesn't quite do it completely, but it does to some degree. Yeah. It does mostly, yes.
Okay.
So you have a
Biodual
shift
so
variable.
The very, very extremely ridiculously small amount that you detect movement of could maybe be the small bit that's getting through, possibly.
No, because it would affect. It wouldn't.
It wouldn't. Okay.
No, it wouldn't, because
Well,
when the balls are moved, you're going to count each other. For instance, when Blue recently did a little on a live demonstration when he moves the balls around. Well, you can detect whether something's generating a magnetic field. It's only if it's something like iron where it actually generates a magnetic field, will that interact. So I don't believe
ridiculous.
lead.
Lead's a great conductor
The
of
dude,
electricity.
the dude Biodual on Debate
Blue
Flat
has-
Earth,
Blue
he
has
said
proven-
that he was
Blue's
doing.
proven-
Sorry, go ahead, Brian.
I'm gonna say Blue has proven that lead attracts and repels lead. He's proven that beyond a shadow of a doubt. That lead attracts lead and lead repels lead within that device, depending on the copper foil. Yeah. Go watch my video where he says that at that point he was joking around, but he did show lead repelling lead. He said at that point I proved lead repels lead until he put copper foil in the right place. He had it repelling.
Well, I think, but that was to do with electrostatic charge. He was just making sure that he was removing the possibility of any electrostatic effects, and he did that by putting the copper in there and grounding everything. So he removed any possibility of electrostatic effects and magnetic effects by doing that.
Say what you want. What he proved is that within that apparatus, he can make lead repel lead, and he can make lead attract lead.
He had a problem with electrostatic charging, I think, at one point, and he eliminated that possibility by putting copper foil in there.
Not the problem. He eliminated that variable, okay, because he went from repelling to varied results to the results he wanted.
He just removed electrostatic by grounding everything.
Yes, he varied electrostatics and got multiple results. He got repulsion.
No, he removed.
He got varied results, and he got attractive results. He got all three and everything in between.
All the same potential, and then you remove all those sorts of things. If you don't understand that, you don't understand what grounding does. He removed all of those sorts of effects by putting the copper
He got
foil in.
repulsion, attraction, and everything in between by varying electrostatics. Call it what you want.
So he removed all the electrostatic issues by lining it with copper. Because the casing got charged or something. So he eliminated that possibility as an issue by grounding everything and putting
conducts electricity, right, Rumpus?
Sorry? Well, I didn't hear you. You repeat what you said?
You know that copper conducts electricity, right?
Oh my God. Yes, that's why I mentioned it. Jesus Christ. You are stupid. If you think that...
You know when you put copper coil in the ground,
you said
draw
you're using
electricity,
it as,
right?
Something that insulates it.
Thank you.
No, it doesn't insulate it. It grounds it. Because it conducts electricity, it removes any charges. My God.
And conducts it to where?
There is a charge to ground itself, Rumpus.
To ground.
How do you think they powered the old telegraph wire?
Any charges to ground to make sure that all the objects are the same potential, and therefore they don't attract or repel one another.
So in his apparatus, the copper wire was wrapped around the object and then went to the ground.
They were all connected. It wasn't wrapped around it, but they were all connected together by copper to make sure that there was no charges of difference between the objects. They were all the same potential and grounded.
Look back in general. I posted a video. It's called an earth battery. It's one of many. And if you take a coil and you ground it, okay, and tie it to and attach it to a conductor like lead, okay, you get charge. Okay, I don't care what you put around it. You could put all the copper you want around it. You might be able to change the charges a little, whatever, get it to change the charges and get different attraction and repulsion. You take a conductor and bury it in the ground, you get charge. Okay, there's
no,
look
you don't.
Look in the video. Put it in general. You can deny it or you can watch it.
Everything grounds out. That's what we call it, grounding out.
Exactly. If you ground it, there will not be any charge. That's the whole point of grounding something.
It's a constant process.
Rumpus, how do you think they got the electricity to power the old telegraph wires? You think they had electric stations in the 1800s? No, they got their power right out the ground with Humboldt
No, they
coils.
didn't. They put power
Coils of copper.
line. they put power on the line, and then you ground it to something like the railway line, but the power was in the line. You don't understand how voltage
Oh my
works.
God, they got patents for the shit, Rumpus. The Humboldt coil. They got patents on this shit.
Do you mean the Helmholtz coil?
Yeah, the Helmholtz coil.
Not the
And there's
Humboldt
other
coil,
ways
the
too. There's
Helmholtz.
other ways.
Yes,
There's
the
other ways. But
Helmholtz
anyway,
coil,
you
yes,
can deny it, or you could watch the video that's one of many. Look up Earth battery. It's one of many. It's easily demonstratable. Okay.
If you ground something, there's no charge between the two things that are grounded. It's very simple. If you're claiming otherwise, you're just nuts.
This is
But
a
just
bunch
like I
of
said,
bull.
man, you're just like
This is a
Jordan, man.
bunch of
People
bull.
like you
First of all,
would get your head out
hold
the
on,
sand
hold
and
on.
open up your minds a little bit. You
How
can
did
come
they
up with these new
isolate?
discoveries, man.
Things are always grounding out. Things are always draining out. Things
You don't
ground
understand
out.
what grounding means.
This is bull. We'll give you all the grounding you want. How did they isolate the downward pulling of your fantasy gravity to the side pulling? How did they do that?
Because if you have something in a different dimension, it can't affect the thing in the other dimension. That's why the Cavendish experiment is arranged horizontally, which means the Earth's gravitational pull cannot in any way affect the attraction between the balls, because the
What
direction.
dimension?
Why not? Why not?
Because one's
What's the different
vertical
dimension?
and the other's horizontal. And when you do that, a force in a vertical dimension cannot be a force in the horizontal dimension as well.
Let me get
Yeah,
this
but
straight.
isn't-
Let me get this straight. The two
Rumpus.
balls, the small little puny little balls, were able to counteract the massive force of gravity of the Earth. This is what you're saying in your La La Land
Right,
fantasy?
you didn't listen, did you? I'll try it again. The force of gravity is acting vertically. The ball's gravitational attraction is acting horizontally. Therefore, there can be no
Wait a second. Rumpus.
interaction. Oh, let me finish my goddamn sentence, you rude twat. You cannot in any way interfere with a vertical force. That's if you understood dimensional analysis and you knew about dimensions, you would know that to be the case. Carry on.
So, Rumpus,
You're in fantasy land.
You don't understand basic things. You've obviously never done any physics, any sort of
Rumpus,
physical
hold
properties
on.
of things falling.
That
Have
is
you,
Hold
hold on,
on.
before I come on to you,
that
Data,
is
hold on.
true-
No, hold on, nearly there, hold on, Data.
If that is true,
Hold on, I'll come with a
let
sec.
me
Give me 5
finish.
seconds, Data. I want to just respond to finish Montreal. Montreal, if you've ever done any calculation with things falling, any physical problem, anything that 12 and 13-year-olds do, you would realize that vertical forces and horizontal forces cannot affect one another. Go ahead, Data.
So, Rumpus, the weight of the
Hold on,
ball
That I
on the
live in
torsion
reality.
bar,
I don't live in fantasy.
the weight of the objects on the torsion bar. Are you saying that it won't change the oscillation?
Correct.
Okay. So if I take the weights off and I have the same oscillation against a straight bar, then why would I conclude that the balls are attracting and repelling each other if I can get the same effect without any balls on the ends of the torsion bar?
Well, you wouldn't get the same effects.
Yeah, you can. Exactly
No,
the
you
same
don't.
effect.
No, you don't.
Yes, you can.
No, you don't. No, you don't.
I've done it.
No,
Yes,
you
you
haven't.
can.
No, you
get
haven't.
an
But if
oscillation.
Blue was to take the balls off the end of the torsion balance that he's
Yeah.
got, those lead balls, if he was to remove them,
Yeah.
then he would not get the effect that he gets.
The oscillation happens regardless of what's on the two ends of the torsion bar.
No, it isn't. No, it doesn't.
Yes, it does. Anybody
No, it
go try it, they'll go see that Rumpus is lying.
No, they won't. No, you're more.
And another thing, by the way, this
I mean, you can see he's done it. Hold on, we've got video.
Hold on,
Sorry,
Rumpus.
hold
Don't
on,
rumpus me.
Don't
rumpus
make
me.
a point. Hold on, I'll give you 5 seconds, Montreal. If you go and look at what Blue does, he goes and moves the balls next to the thing, and then the oscillation begins. With
now
a
my
large
turn.
amplitude. Go
Now
ahead.
this fantasy, Rumpus, this fantasy La La Land story apparatus that Blue built is based on mass attracting mass, correct?
Correct.
Well, we all know that mass does not attract mass.
We all know
It's
it
been
does.
replaced by the other fantasy story, by the other moron who claims the fabric of space-time. So double whammy. I mean, this is sheer and
same thing.
utter fantasy.
Einstein's
Rumpus.
equations reduced to Newtonian equations.
Rumpus,
Why do you feel interrupt? Well, I'm just talking to
I just want to clarify one
hold
thing.
on, let me just.
I want to clarify
one answer to
one
Montreal,
thing.
and then I come back
One
to you.
thing.
Montreal,
One
I'm
thing.
going to reply to Montreal, and then you can come back to me. Montreal, Einstein equations reduced to the Newtonian ones in our 3D world, Einstein would be perfectly happy with using Newton. And in fact, he said so. He said, I would not, anything I've done would in any way take away from Newton's equations. He would support Newton's equations totally. Go ahead, Data.
But
yes,
they don't
we know
match.
in your
They don't match
fantasy,
observable reality.
mathematics. Give me a second, please, Data. We know in your fantasy reduction, fantasy mathematical
All the
model,
experiments
it
support
works,
the Einstein and
but
Newton
in
equations.
reality, it doesn't. Go ahead,
In
Data.
reality, we got Blue's experiment that proves it. Thank you very much.
So, Rumpus, just to clarify, you believe that man, using the Cavendish experiment, can calculate the density of Earth?
Correct.
And you believe that is deduced by watching an oscillation pattern that you just confirmed the downward vector of gravity doesn't affect the vertical or the horizontal oscillation.
Correct.
But in the same breath, I just told you if I take the balls off of the torsion bar, you will still get the oscillation.
No, you won't.
And you deny
you
that, right?
Correct.
Okay,
You
so you
don't.
deny that. Okay, awesome. You
Correct,
deny that. Thank you. Anybody just hang a string, get a copper bar, and you'll see the film it, and you'll see an oscillation pattern.
He's in fantasy, bro. He doesn't think downward force will affect. He's in fantasy, sheer fantasy.
You don't understand basic physics, I'm afraid, Montreal. You've obviously never done a single calculation like this. You're not qualified to have an opinion on this subject.
Now, Rumpus, I have another question for you. I can use a pendulum and the rate of oscillation based on the cycle to determine the rate of gravity, right?
Correct.
So if I have three different objects and I do this pattern and I use a formula and I derive the calculations of the rate different between three different items, what would you say to that?
Well, there is a formula for the oscillation of a pendulum.
I have
it's
a
2
formula.
pi square root of L over G. So it's the Can I just finish my sentence?
I'll tell you what the formula
Can I
is.
just finish my goddamn sentence?
Sorry, go
The
ahead.
period of oscillation of a pendulum is square root, I think, of L over G, which means that the period is just dependent on the length of the pendulum. Go ahead.
So you can take the time and divide it by the cycles to get the rate per second. And
No, the
then
cycles are the rate per second, you idiot.
So you can take the 4 pi squared times it by...
What's 4 pi squared got to do with this?
This is the calculation for the
No, it's
pendulum.
not. You've got it wrong.
Okay, so if I show
That's
you...
not involved. You're using the
so
wrong
you're the
math.
second person... Hold on, let me finish. You're now the second person that denies... I didn't get the formula. I didn't invent
Show
the
me the formula.
Hold on. You're now the second person. Blue's the first. You're the
Well,
second.
show me the formula. I'll tell you.
Hold
what
on,
the formula
Data.
is.
I'll tell you the formula.
Well, give me
I'll
the
tell you
formula
this
then.
right
Give me a
now,
link
just
to the
show-
formula.
4 pi squared multiplied by the length of the string divided by the cycles per second squared.
Maybe
Will you
just
get
show
the
them a
rate?
couple data. Maybe just
Hold on.
Data. Maybe just show them a cup
Shut
of
up,
water.
fucking Jeremy. Shut up.
Just
So
show them a
hold
cup
on.
of water, bro.
Shut the fuck up. So anyway, you confirmed that it's a bogus formula, right?
Well, you're bound to have mulched it up. It might have been valid for something, but you've misapplied it or misunderstood it.
Okay.
Until I see it, give me a
Okay.
link to it, and then I'll tell you whether it's valid or not.
Okay. So it comes from an educational science channel.
Yo, how about just giving it to me and we'll take it from there? Why are you deflecting? Why don't you just give it to
all
me?
I'm here to do is to prove that you guys deny your own
How
calculation.
about giving me the formula and then I'll tell you whether it's valid
I
or not?
already gave you the formula.
No, you can't reply.
I
You're
already
incapable of
gave you the
reciting everything
formula.
correctly. Give
You
me a
said
link.
You said it's
Give me a
dumb.
link.
It
Yeah,
doesn't
but you-
work.
No, not the way you described it. You'll have misunderstood it. It might be a valid formula for something else, not what you described it for.
I'll give you a calculation. If I have a 12-inch
Give me
string,
the link to the formula, and I'll tell you whether it's valid
hold
or
on,
not.
hold on.
It's in the
Use
book,
your-
Rumpus.
Use your formula, okay? I'll give you the
Give me the link to the formula,
Right
and I'll tell
now-
you whether it's valid.
right now,
no, I'm
Rumpus,
not going to
I'll-
write down what you say
There's
because you
only
get
two
everything
variables
wrong.
we need. We need the
You
length
get
of the
everything
string.
wrong.
We need
and
the
I'm not
length of
going
the
to write
string.
down a random formula you're reciting to me incorrectly. Give me a
Okay, so
link
here's
to the
how we do it,
formula.
Rumpus.
Give me
Here's
a
how we do
link
it.
to the
Let
formula.
me know when
Why are
you're
you
done.
reluctant to do that?
Let me know when you're done, Princess.
Why are you reluctant to give me the link to the formula?
Let me know when you're done so I can speak,
should
please.
be-
Why
You should be asking for the cup of
are
water.
you reluctant to post the formula or a link
Let me
to
know
the
when you're
formula?
done. Let me know when
He
you're done.
just gave you the formula. Test it out yourself, dumbass.
he's not trustworthy enough to do that. He gets everything
Let
wrong.
me know
He'll
when
have
you're done,
misremembered it.
Rumpus.
So
Let me
why
know when you're
why
done.
are you so reluctant? I mean, could you please answer my question rather than just...
Let me know when you're done.
Yeah, well, no, I haven't done until you've answered my question. I'll be done then when you've answered my question.
Let me know when you're
You're
done.
doing an appeal to format fallacy.
Yeah, so why aren't you
Rumpus, let me know when you're done.
The equation.
Post the formula. I'll post me a link to the formula.
He gave you the formula.
When you're done.
Well, I'm not done until you've posted a link to the formula, so it's in your control.
So you're going to drag it on. Just let me know when you're done, and I can explain.
I'm going to carry on asking you for the formula and a link to it, and then I'll tell you whether it's valid or not.
Is this the Rumpus show or what?
With the cup of water thing
I just forget.
and the
If he's not
pilot?
prepared to post a link, I'm happy to move on. If he's not prepared to post a link to the formula, I'm happy to move on to anybody
So
else.
I told you the formula.
No, you won't.
And
You've
now
got it wrong.
Now I'm willing to give you the variables that you can input.
No. I'm not going to accept any formula from you because you'll have got it wrong.
Okay. So you ready? Let me know when you're finished, Princess.
Yo, the pilot that saved the 76 lives. He had a co-pilot, right?
Has he given the formula to anybody else?
You suck a dick right now.
Has he given the link to anybody else so that we can look at where it came from?
So, Rumpus, I'm going to give you the calculation. I'm going to give you the variables, okay? The length of the string is 12 inches.
Just hit us with the link to the formula, bro.
Shut the
I'm
fuck
not going to look. Give me a link to
Take
the
the
formula.
length of the string. It's 12 inches.
Yeah, I'm not going to.
And the rate of oscillation is 1.09 seconds.
I'm only interested in the formula. I'm not interested in numbers.
Okay.
Because the formula tells me what's going on. If you just give me numbers,
let me know when you're done.
If you just give me numbers, I have no idea where the numbers came from. I can't validate numbers. I can only validate formulas.
Doesn't matter. We can start with the length of the string.
It's already been tested. He ain't interested in testing it himself.
I'm more than happy to, but at the moment he's just randomly saying he's got a formula, and it doesn't sound correct to me, and it certainly doesn't sound to match what he's talking about. Okay, I'll give you a link to the formula for the swing of a pendulum.
So
let me just go and get
Rumpus,
that. I'll put a link.
If you have a length of a string of 12 inches, which is 0.3084 meters, and you have a cycle rate of 1.09 seconds, we both should be able to determine the rate of gravity.
Cycle rate means nothing. You see, you're using the wrong terminology. This is why you can't be trusted.
So you can take the
There's
time.
no such thing as cycle rate. It makes no sense.
You can take the cycles per second. So you can take the time.
Now you're changing, right? You're gradually getting there.
So you can take the time and divide it by the cycles. Okay?
Why would you want
to do that? So what I do is I count 30 cycles and then I quantify the time, and it gives me the rate per second of cycle. Okay?
The rate per second is a meaningless thing. You mean cycles per second.
That's
the
what I
rate
meant.
per second is not.
So hold on.
That's
So
not a scientific term.
I gave you two factors.
You see, Brian, this is why I can't trust him.
God,
he cannot get any of the terms right.
Stop.
But he's giving me a load of crap,
It
Paige.
doesn't matter.
Every other word he's using is wrong.
Because
he keeps on making errors. Every word he uses is wrong.
After he's finished, rebut him. But until then, just go on mute. Please.
Well, I don't know why he's able to.
There are other people here, Rumpus. I
other people
want to
speak
hear
then.
what he's saying.
But he could give me a link to this formula, and then this will all be over.
No, you just said it was wrong when I told you what it was. So did Blue. And then I asked Blue for his Cavendish formula, and he was silent. So, Rumpus, I'm just going to give you two variables. Is all you need to know.
No, it's not all I need to know.
1.01. Let me give you, hold on. 1.01 cycles per second. And the length of the string is 12 inches, or 0.3084 meters.
Also, if you don't believe that, we gotta
provide me the answer using your formulation, please, and I'll give you my answer. Okay.
Sorry, I posted the wrong thing.
If you don't believe that formula, we got a glass of water on an airplane dashboard. Keep that in mind.
I've posted it. Sorry about posting.
Presented by two fucking Globers.
Right, I've posted the formula for the period of a who's just delete?
Jeremy, that glass of water, that pilot definitely had a co-pilot, right?
Right, I've just posted in the chat
the
formula for the period of a pendulum.
Why would that even matter about a co-pilot? Rumpus, shut up.
Because that would mean it's two pilots, one cup.
There's no such thing as co-pilot.
There's another fake flat earther pretending to be a
Right, okay, so now here I've just posted the formula for the period of a pendulum, and it's 2 pi times the square root of the length of the pendulum over g. That tells you the period of a pendulum. God knows what data's talking about. I've just posted the formula.
So, Rumpus, I just gave you the numbers. Can you tell me what your result is?
I don't care what numbers you've given me. Well,
Why?
okay.
Is the rate of the string and the time per cycle all you need to calculate the rate of gravity? Yes or no?
Right. Well, so what you're talking about a pendulum? Is that what you're describing? What's happening with a pendulum? Is that what you're talking about?
Nope.
Well, I don't know what you're talking about then. I'm not going. You haven't told me what you're describing. What physical scenario you're describing?
The rate of gravity.
The rate of gravity. There's no such thing as the rate of gravity. Again,
the
you used the
gravitational
wrong
force.
term.
Sorry. The 98.8 meter seconds is
That's
a rate.
the acceleration due to gravity.
So
and I've given a
doesn't matter.
formula.
You're calculating it as gravitational force, right? The
acceleration due to gravity is an acceleration, not a force.
Anyway, you can calculate
acceleration due to relative density.
It's a formula I gave you.
No, you didn't give me. You haven't given me a formula. I have not seen a formula.
I gave you the formula.
No, you haven't. You have not posted a formula in the chat.
So you ready? You already said it was wrong when I gave it to you the first time, so I'm going to give it to you.
Well, how about posting a formula and have a look at it?
4 pi squared.
Now post the goddamn formula,
I'm going to tell you what it is, Rumpus.
No, I'm not interested in you telling me.
Rumpus, this is an appeal to format fallacy.
No, it's not, because you.
Yes, it is.
No, be quiet, Jeremy. When people are exact and understand science, they make a point of that there's no ambiguity.
Let me know when you're done, Princess.
Yeah, be quiet. Stop interrupting. And I have posted an exact formula. Yeah, stop interrupting, twat. So I have posted a formula.
Princess.
Yeah, you stop interrupting and being a twat. You rude moron.
Yeah, stop being a princess, and I'll let you finish.
Stop being a twat. So
okay,
I've posted a formula for the period of a pendulum. Now I've no idea. We've no idea. He hasn't described what he's talking about, so we don't know. So I don't care.
The over/under on how many times you were going to say twat for the show is 37. So
okay, jolly good. Well, he's behaving like a twat. I'm prepared to post formula. He's not.
Another one.
The story.
So I'm telling you the formula.
No, you're not. I want to see you. I want to see it appear in the text, and then I can start thinking about it. And then you haven't told me whether it's for a pendulum. You haven't actually told me what it's a formula for. You haven't told me what it's a formula for, and you haven't given me the formula. Until you do, I'm not going to bother to do anything.
He's trying to tell you the formula. You won't listen.
No, I'm not going to have him dictating it. I want to see it posted in the chat.
Yeah, type it out.
Let me know when you're done, Princess.
Data, type it out for him.
I'm done with you. I'm not prepared to continue talking to you until you post a formula and you tell me what's a formula for. Until you do those things, I can't discuss it. So anybody else? I've no interest in continuing to talk.
If I tell him the formula verbally, so everybody can hear
no, I'm not interested. You'll get it wrong.
So if I tell the formula to everybody so they can hear it, that's not good enough?
No, it's not good enough. I want to see it typed in the chat.
You're a fucking princess, dude.
I want to see it typed in the chat to make sure there are enough.
You're a little princess.
You'll cock it up, and then we'll be arguing about what you said. And then we'll be arguing about what you said.
As he says it, write it down, and then repeat it to him to make sure it's right.
He's capable of typing it in the chat, and so he can do it. I'm not going to do his work for him.
Just look at Brandon's screen.
You guys deserve each other, man.
Look at Brandon's screen. It's got all the proof you need.
It's called Friday Fights, right?
Rumpus, look at Brandon's
screen.
It's got all the... I said, look at Brandon's screen. Look at Brandon's screen.
Oh, I see. Okay.
It's got all the proof you need right there.
Yep.
Boom. Shut it down.
He's speechless.
Well, you'd be stupid. I mean, Brandon just being stupid. Well, Jeremy, you're being stupid. One of you two is being stupid if you think it proves anything.
When have you ever known me to be stupid?
Well, I mean, you do make a habit of it. Sometimes you demonstrate you've got this. You have got some potential to not be as stupid as you are. At least that's good. So, but you do recently.
It's ridiculous.
You do recently. I mean, for instance,
what a quintessential English.
You actually interact and you actually listen, and you do. Even if you say something stupid, at least you take on board what's being said to you. Unlike Data on the Plane, who apparently denies acceleration as a thing. At least you don't do things like that. And you occasionally say something intelligent, like the good one you mentioned was, had we considered the weight of the line, the stretching of the line in Brun and White's word experiment, which is a very good point. So you do make some intelligent points, but you seem to recently have got worse for some reason, don't you? And you show me a picture of a glass of water, so what?
Yeah, you have no argument against it, obviously.
I made up.
Well,
that
I approve.
point.
I approve of it. It's perfectly fine. I like glasses of water, and that looks like a fine glass of water. Why should I disagree?
I know that's all he needs to do, but he's not going to because he knows he's wrong because he's proven wrong.
I'm supposed to disagree with a glass of water, am I?
Big G.
Whoever that is, you're breaking up, you idiot.
Are you talking to us, Tony?
Moron, you were talking about Big G.
Yes. Well, I didn't actually talk about. Well, I don't think I did mention Big G actually. But anyway, carry on. I'll talk about Big G if you want me to.
He was talking about Little G.
Talk
Yeah, I was
about
talking about
point
little.
G.
Yeah, we were talking about little g, but we
Point
talked about
G
Cavendish
is what
briefly,
you
which
need to focus
implied
on.
big G. Presumably, you don't know the difference because you're a moron, whoever that was.
You need to focus on point G, not big G, little point G.
Point G.
You ready to write down the formula, Rumpus?
No, you
Write
can
it
write
down.
it down in the
Write it
chat.
down,
No,
bitch
I'm not going to
boy.
write anything down because I'll be accused of getting it wrong. You write down the
Down,
formula
and then
you
write
want
it
me to
back
repeat.
What
up.
if I write it down?
Awesome. Ready?
Brandon, you write it down on a big screen. Put it on a big screen.
Fucking children, I swear to God.
All right.
Well, this
Put
is
it
a
on a big
twat.
screen.
I've already wrote it
Why
down.
should I be
Hold
making his formula for him? It's just ridiculous that he won't write it
Rumpus,
down.
stop.
What a
Brandon's
twat.
gonna write it down. Just
What a
stop it.
moron.
Stop
I
it.
mean, I really mean this sincerely.
Is
You
it,
get
The
the
guy is an
gravitational
absolute twat of
acceleration.
the first
Orifice for
order.
2 seconds.
Let me
Rumpus.
know when you're ready, Brandon.
I mean,
Let me
a
know when you're
twat
ready.
of the first order.
Let me know when you're ready.
Chill for 1 second. Go
I
ahead.
think I'm ready.
I mean,
is this it?
Rumpus,
Okay, Rumpus,
shut up.
can you hold your panties for a second? All right.
He's doing it right now
So
for you.
4 pi squared multiplied by the length of the string divided by the cycles per second squared.
Hold on.
That will give you the rate of the gravitational acceleration.
Cycle per second square.
Yes. Now, how do you get the cycles per second square? You take the time divided by the time you've analyzed. Let's say you counted 28 cycles in 45 seconds. So it would be 45 divided by 28 cycles would be, in this example, 1.607 cycles.
you could see why he
Per
didn't type
second.
it. He doesn't know what it is. He can't recount it properly, and that's why he's trying to detach himself from it. He cannot write it down because he's a moron.
Rumpus, little princess, are you okay?
I'm
Hey,
fine.
what I-
You're the one with the problem, mate.
A moron of what order?
Hey, what I'm seeing.
First order moron. I mean, this guy is, I mean, the most stupid. I think probably on the panel, I can't think of anybody immediately who's more stupid than he
Okay,
is.
what I'm
If
seeing
someone
here,
wants to make an effort.
Rumpus, what I'm seeing here is a problem you have with science and math, and not
Exactly what I'm
understand-
highlighting.
Anybody
not-
who,
Okay, hold on, I'm almost there, dude. And
Okay.
you understanding math and anyone explaining math to you is just the tip of the iceberg. There's a whole 90% of this problem that's below the surface that you're not even aware of.
oh,
it's
I
a
am.
good-
I'm aware of everything.
Good thing you are here.
If you want to tell me something I'm not aware of, go ahead.
Now, Rumpus, is that formulation incorrect to calculate the gravitational acceleration? Yes or no?
I'm looking in general, and there's nothing appeared there. Which one should I be looking in?
So originally, when I said it to you and I
Hold
repeated
on,
myself,
Brandon, where should I be looking, Brandon?
you said it was wrong, and I was
Brandon,
an idiot.
where should I be looking to
Same
see
as
this?
blue, and
It's on
yet
my
I took
screen.
it
Where
from,
It's on
should
my
I be
screen.
looking
It's on
to
my
s-
screen.
Oh, you're on your
and I
screen.
took it from a science channel. Oh, make sure that the rates per second is in
So
parentheses.
you stole it.
I stole it, eh? I stole it, did I? I
So you
used
took
it
it
against
from
fucking
China.
Rumpus and Blue to show they're idiots. The point is, put it in parentheses if you can, but I just proved these guys are fucking morons and denying their own maths.
Is that right, or is
So,
there more
what-
parentheses?
Lots of fake flat earthers.
What a mess.
Regulations of being objective and like fair are that you're called a fake flat earther by globe earthers
There
and
you
a
go,
fake
fake flat
globe
earther
earther
speaking.
by flat earthers.
Fake flat earther speaking right now. That's you. Yep.
Hey, Brandon, can you change the font for everything to Comic Sans? by
Yeah,
any
we're
chance?
gonna need a Comic Sans for this one.
Okay, let me do that real quick.
I mean, let's get our priorities straight, Brandon. Come on.
Exactly right. Jeremy.
Tell him, man. So
You guys are.
There we go.
You see, I mean, this guy's such a moron. He doesn't realize that cycles per second is the same as frequency. That's how stupid this guy is. An utter.
Is that the correct formula?
Utter moron.
Do you
For
know
what?
that
I've
you
no
can
idea.
calculate? You can calculate the hertz with it too, Rumpus. Would you like that as well?
Calculate the
correct
hertz.
formula.
That's
What-
right. Your frequency, right, bud?
That's right. Frequencies in hertz. Yes, that's correct. Well done. You got something.
Would you
right.
like the formula for that, numbnuts?
Well, I don't know what this is for. This is for a pendulum swing, is it? Is this what you're claiming? You haven't given
I'm
me
not
the
claiming it.
physical scenario.
I'm
You
not
haven't
claiming
actually
it.
said
I took
what
it
this is
from
the
a
formula
science channel.
for.
I used it from a I took it from a science.
Yeah, we know you did, but you haven't said what it's a formula for, you utter
to
moron.
calculate the gravitational
So
acceleration.
G, little g is equal to that. Is that correct?
to calculate the gravitational
He
acceleration.
hasn't said, you see, this is why you've got to get people to write things down, because we've no idea what that's equal to. We've no idea what it refers to. And that's why, because I am specific and very careful, I don't accept people giving crap articulate. I want to see a formula where the rigor of mathematics involved. And we've no idea what this formula is equal to, because he doesn't know, because he's just
Isn't there
doesn't know
supposed to be an
anything about what
equal
he's talking
sign?
about.
Should there be an equal sign in there somewhere?
Yeah, he's saying it's equal to something. He's saying it's giving you the value of something. We've no idea what. He hasn't said what it's equal to. The guy's a moron of the first order.
I don't know.
Gravitational
Sometimes I don't know.
acceleration, Rumpus.
What? Oh, it's an acceleration
Rumpus.
now, is it? So is it equal to G,
Put
is
in
what you're
Rumpus.
claiming? The guy's an... Oh, is that Blue? Oh,
Dada.
Blue, you wouldn't believe the stupidity I'm being subjected to here.
Oh, Blue's in. Blue's in.
And he's talking to me.
There, we got an equal sign in there, so we know what it equals now.
Yeah, that's exactly what.
But hey, Brandon, when you put equal,
Blue's trying to say something, Data. For
when you
once,
put
let him
equal, put
speak.
G at the end of it, okay, bud?
Oh, he's afraid of me. He's not going to stick around if I stay in here.
Yeah, go ahead, Blue.
Because that's
Say what you-
the
Blue,
pendulum formula.
you're an idiot
solved
too,
for
huh?
G, okay?
You're an idiot as
And what
well. You said
and
the
the
formula.
mistake he made when he tried to tell it to me
Fucking
earlier
idiot.
is the same mistake he's making again now. He told me not divided by t. It was not divided by t squared. He said t, but he's got frequency and period confused. This does not solve for
So again, you morons are admitting you're
Data.
disingenuous
The
and you're
pendulum formula
idiotic.
solves for.
It comes from a
period,
science
not
channel,
the
and I'm
frequency.
using it against you.
G, right? Yeah, I thought so.
I'm using it against
Look it up.
and you guys are denying it.
We knew. Well, he won't give me a link.
But
to
it
where
even
he
gets
got
better,
from.
guys. It even gets better.
He
You can
won't
apply
give
it
me a
to
link where he got
reality.
it from, and you can see the fact what we've got written on screen. He never said what it was equal to. So this
No,
is
he said
why
change it to
on the
G.
bigger formula.
Change it to G, Brandon.
So he's a moron,
G.
and so he's got mixed up, and he didn't understand that cycles per second were frequency earlier. I mean, the guy is an absolute.
Would you
moron.
like me to run? Would you like me to run through the formula with you?
Give us me the
Maybe
link.
you're- maybe
Where
you're
you clearly don't know what this is. You've clearly no idea how
Hold
this
on.
is derived.
4 pi squared multiplied by, in parentheses, the length of the string divided by the cycles per second in parentheses
Wrong.
squared will equal G. Is that wrong? Hold on. Was that Blue saying it's wrong again?
Wrong.
Yeah,
It's
Blue
not
said
the
it was wrong.
frequency. It is the
All right.
period. It
Again,
is not
it's not my
frequency, it is
formula, you
period.
fucktards.
You got those things upside down,
Give
Data.
us
That's not
a
my
link to the
formula.
Got 'em
formula.
absolutely ass backwards.
This is
Exactly,
priceless,
you
guys. You
moron.
realize how disgusting
See,
this
need to
is.
go
guys,
back
this is
and look it
why
up.
I
These are
wanted a
two
link to the
disgusting
formula, you see.
human beings.
You see, he's got it wrong. He's recounted it incorrectly, and that's why I wanted a link to the formula. And I've been proved totally
Exactly.
correct in being demanding that he gave me a link to the formula, because he doesn't even know what the terms are. Hence, he gets them mixed up. He didn't even know that it was equal to something, and this is why I wanted a link to the thing. And this is, he can't articulate things scientifically, and that's why you do not ever believe anything he says, because he can't even remember or comprehend what he's read and then repeat it to you correctly. The guy is a first-order moron.
Can you at least tell us where you got the link, Dada?
He won't do
Don't
it. He
post
won't
it.
do
Can you at least tell us where you got it from?
He won't
That's
do
not
it. I've asked him about
unreasonable.
20
It's not
times. He
unreasonable.
won't do it. Go ahead, Bansor. You ask him. See if you get anywhere with him. Go ahead, Bansor.
Dada, can you please at least tell us where you got the link from? Don't post it. Just tell us where, what source.
The best part about it is I'm going to use your own globe shit against you to prove
See, he won't.
how fucking
See,
bullshit
Bansor, he
this
just
is.
deflected from that.
It's fucking
This is
weirdo-ness.
This is a real
So here's
first
the
order
picture.
moron and wanker.
Here's
You
a
see, he's
picture
been
right from the
dyslexic.
website.
For some reason, he's embarrassed
There you
about
go.
telling us where he got it from. He's
There you
embarrassed
go.
for some reason.
I just
It's probably
posted in
from
the
some
chat,
child.
Brandon.
It's
Take
probably
a
from some
look at
child's
it.
site.
I took
So-
that right out of a science channel and used it against you, and you guys said the
So
formula.
he won't do it, you see, Bansor. That's what this guy's like.
Because I got more
I would have
coming.
no
Oh, you
problem
got
with
it wrong,
psychology.
too.
I got more coming.
Still
Don't
got it
And you got it
wrong,
wrong,
Data.
yeah. You got it
I
wrong.
still
You
got it
didn't
wrong,
copy it.
Data.
You're a moron of
It
the
is not-
first order. Just
So the
amazing.
Frequency.
The length of the
It's
string
not frequency.
divided
It's
by the
period.
cycle per second squared. will give you
No,
the rate of
no,
acceleration.
no.
Ah,
A
it
period
looks
in
like it
seconds.
came from
dummy.
Khan. Right, it's come from Khan Academy, I can see here, I think. It's come from Khan Academy. Right, which is a good source. Now he's actually right, so it's come from Khan Academy, and that is a good
Oh
source
wait,
of
the
information.
formula was wrong before.
Well, you didn't tell me what it was for. You didn't tell me it was equal to, you twat, did you?
Equal to G, little G.
You didn't say that. You've only just started to say that.
Doesn't matter. It's talking about
Yes,
a
it does
pendulum and
matter. You
calculating
didn't say what it
oscillations.
was equal to.
But you know what's
didn't
really
say what
awesome
it was in
about this
relation
formula?
to.
You know
This
what's
is
awesome
such an
about this formula?
unproductive exchange.
And
You know
as
what's
Blue
awesome
said,
about
and
this
let's see what Blue said. Do you see that T squared? That is period. So as Blue said, he
Cycles
gave you
per
the
second
wrong
is
thing.
a period of time, you fucktards.
No, it's not.
Cycles per second? It's not
No,
over period?
it's the seconds per cycle.
seconds,
You've got
dummy.
it round the wrong way. So as
Cycles-
I told
the
everybody
cycles
on
per
panel, he
second.
would get it wrong. He's
You know
got
what the
it
formula
wrong.
for cycle
And
per
Blue's
second is?
absolutely
Is
correct. He's given
time over the cycle.
Where's
yeah,
the
and not
fast forward
cycles
button?
over
Come
time.
on.
You said cycles per second, and that's look what's written there. Cycles per second. Brandon's written in for what, and that's what you said, and that's not equal to T. That's 1 over T. You are a moron.
To get the
And Blue
answer
is absolutely
is
right.
time
You couldn't
divided by
even recount the
cycles.
formula, and
So
that's
for
why he
instance,
didn't do it.
you
He
know how they
doesn't
got the
understand what these formulas are. He doesn't understand
I wish
their
this wasn't
formulas.
live so I could skip ahead.
The guy is a moron of the first order. He can't even.
God dang it.
He doesn't understand the formula that's on screen in the Khan Academy
Okay,
video.
So what's the
whatever.
formula
Listen,
You
I got
wish you were
two
Adam
lead balls
Sandler and
hanging
click
up.
right now.
I got two lead balls
Yeah.
hanging up, grounded, and I got a voltmeter right here. Anybody who doesn't think that you can draw current out of the earth, I don't care if you
Brian
tell me
went and
how
did an
much. I don't give a
experiment just
shit.
now.
I got it. I got lead balls grounded to the earth right now, and just dry lead. Well, they're lead plates where I melted down the lead, just hanging. And I don't even have. I got them a foot and a half apart, and they're fucking getting current. God damn it! Now,
And
who wants
what's
to deny
more,
that?
How could you
that's
tell
not
they got
equal to
current? Do you have a
Just the
voltometer?
You
punchline
don't
to
have
this.
any idea how to use your damn multimeter,
Here's
Brian.
the
Come here,
punchline
give
to
us a
this.
break.
This formula doesn't
Really,
even
dude?
equal G. This formula that he said is equal to G, you can see from what's cancelled out that it's not equal to G because it ends up with being 12.2 meters per second. So it's the acceleration at other parts. It's not G. So every part of this thing that he recited to us is wrong. As I predicted.
Are you
well
sure?
done, Data. You've just given us video proof that you're an utter moron.
Are you sure it's wrong though?
Absolutely.
It ain't wrong.
The formula on screen is correct, but it's not equal to G.
Yeah. The formula on the screen that he's been trying to give you the whole damn time, and then
It's
right when you
wrong.
find out it's from Khan
The
Academy,
one, the
it's a
Khan
great
Academy
formula.
bit of it is correct, but it's not
Dude,
equal to G.
then shut
it's
up!
Not, it's Brian, you can't change the subject. We're in the middle of this. Wait for a second. The formula on screen, the Khan Academy bit, will be correct, and it's clearly giving an acceleration as some.
You haven't
parts
even
of some swinging.
applied it, Rumpus.
Be
You
quiet.
haven't even applied it,
Be
bro.
quiet. This is not equal to G, so he lied or misunderstood. Well, that lie's wrong. He's so stupid, he didn't realise it was equal to G. He just knew it had something to do with G because he saw it was crossed out in the formula. He recited it incorrectly. He told you incorrectly what it was equal to. He didn't understand that T was period. He didn't. He told you it was cycles per seconds.
To make yourself look like a loser.
Absolute.
I just posted in the chat.
You are a
and I
moron.
told you it had everything to do with the rate of gravity.
A wonderful demonstration
whether
of
I was
why
specific on what
everything
G,
you say
there
has
it
to
is.
be expected to be wrong.
This is going in the book, Rumpus. This is
Excellent.
going in the book. So
It's an absolute video demonstration of why Data is an
I
absolute
just
first order
proved
moron.
how much you guys go through to fucking lie in real time, and the Glober that's offended,
moron.
the
claimed it was
sphincter
equal
there
to G
wants
and
to
it's
fast
not.
forward because you, Rumpus, are one of
claimed
the
it was equal
worst
to G and it
debaters
wasn't.
ever.
You utter moron. I mean, it's just
What-
amazing.
What did you do, Brian?
I used your own formula against you to show you just how disingenuous you guys are.
So we still don't know what this is for. Well, apparently, if it's equal to G, it's equal to 12.2 meters per second squared, and it's
As
clearly not
what
equal to
I've
that.
been saying this whole time, you fucktard.
No, you haven't been saying anything all this time. You've been getting things wrong, like the period and cycles per second.
Yet I can use it and calculate the rate of acceleration to show you that it's inconsistent based on different matter, right? That's
You're
the
not
whole
going to give us
point
a
of
link
me.
to the. Why don't
That's
you
the
give us
whole
a
point of
link?
me bringing this up.
Well,
is
give us a
actually
link to the video
give people
that
this
this came from.
formula to go hang a pendulum out and use this formula to show you that the rate is not consistent based on
It is
different matter.
absolutely consistent.
It's not. And that's the
It
whole
is
point of
absolutely
showing you.
consistent.
But it's another thing that will come later on.
But can we just
Again,
acknowledge
this
that this
entire
does say
conversation
G
is
Oh,
equals?
this from someone who doesn't understand what T means in that formula.
This
Quite
says
amusing.
G equals And this looks like what he said. What am I missing here?
That does, yeah, I agree with that. Does actually, yeah. But notice he's refusing to give us a link to the actual thing.
Oh, now you're gonna fall back on we don't have a link to the actual thing. He did.
Well, he got.
First
he
it
gets everything wrong
was
about
you don't
this.
know the formula. Second it was you got
Well,
it wrong.
Well, he didn't.
Now
He
it
did
does
get it
equal
wrong.
G, but you got it from a
But he got
source
it
I
wrong.
don't approve of.
He gave you wrong. The formula he gave you, he didn't
I
understand
didn't.
what T squared
At all.
He didn't know what T squared was,
Oh,
and he
I
got
didn't know
that
what
wrong.
T was. I didn't know what G was, but yet I gave you the whole formula plus I can calculate it. You're
Now,
a moron,
you
dude.
didn't know you got the formula wrong. The formula you gave to Brandon that he wrote up was wrong.
Work that out.
It was wrong.
New subject, please.
It
This is a dumb
was wrong
spot.
data. It was wrong
reason
data.
why it's
It
dumb
was
to
wrong.
you, dude.
Listen, let's get on
The
to Brian.
formula you
Guys,
gave to Brandon
8 inches
was
apart.
wrong.
The other guy
Hey,
that
Brian,
no,
what did you do?
Between
the
the two
reason
lead
why
plates,
it's dumb
okay?
to you,
There-
dude, is because you don't know how to use it. It proves that gravity isn't constant.
The
Listen, you
formula
idiot.
gave to Brandon
No, hold
was
up,
wrong.
hold up. Listen, you
fucking
fucking
flat
idiot.
earther,
I didn't
dude.
say it was
Fake flat
dumb. I said it was a dumpster fire.
You're,
So
yeah.
learn to fucking listen.
Learn the equation. It'll prove the rate of
Learn
gravity.
to listen. Learn to use your ears, and maybe this conversation would be better.
It will prove the rate of gravitational acceleration.
But he doesn't
is
know what
not
T
constant.
means, does he? He got that wrong. And he won't give us a link to the thing so I could go and check what this G is, how this was derived. He won't give us a link to it. It's from Khan Academy, I can tell that much. But for some reason, he doesn't want us to tell us where he got it from. But I think it's from Khan Academy,
It's
which is a
not
credible
from
source.
Khan Economy either. Okay.
It's not from Khan Academy. Okay, it looks
No.
like it. Okay, well, for some reason you're reluctant to tell us where it came from. I don't know. Well, presumably
Because
you're
I'm
trying to
going to
deceive.
use more
You're
of
trying
these
to.
formulas
You're trying to.
against
You're
you
trying to
just
deceive us for
show
some
you
reason.
just how bad you are, Rumpus.
What? Yeah, this is from the guy who doesn't know what the T meant in that formula. Well done.
What are you doing, Brian?
The formula was
Brian,
wrong.
what are you doing?
I got 2 load weights hanging up, and I'm trying to do this one-handed. If anybody wants to look at my screen real quick,
Yeah,
I only got 5%
go.
on my phone.
Okay, Brian, I'll have a look. This guy doesn't know what T means, and so we can take it from. He doesn't know what the hell he's doing. So what are you doing, Brian?
I got.
Dan, how do I get your
okay, see
video?
my meter? Can you see my meter?
Just
Sorry,
click him. Just
I
click
am clicking.
Brian's
I'm clicking
name.
on him, and I don't get.
Are you
I'm
showing
not getting
something?
any-
Yeah, I see it.
2 stones hanging in the air.
Why does this not?
No, they're melted copper plates.
Oh,
No, lead. It's lead.
Where is he showing something? Oh,
On his
Click on the
Screen.
title.
Brandon.
Click on the show channel thing, Brandon, and then click on his image
Oh, he's using his
on the
camera.
right side.
Oh, okay. All right.
Yeah, it doesn't. By clicking on his name, it doesn't work for some reason.
Hold on, this is hard
But
to
it's
do
not
one-handed.
grounded, Brian. It's not
Yes,
grounded,
it
is
is.
it?
It's fucking grounded. Yes. It's right
No,
it's
you
right
haven't
on the
got a
ground.
wire, Brian. You haven't got a wire
fucking
going
wire
from
in
the
the ground.
lead.
he's grounded it, Rumpus. He's grounded it. You just
So
didn't
that's
see it.
that's a conducting wire, is it?
Yeah, right in
He's,
the fucking
he's grounded
wire.
it.
See that?
It's a copper wire going from there to the lead weight.
To a lead fucking
Yeah.
plate. Okay, now I got them about 8 inches apart. And I had them a foot and a half apart, and I was showing a charge. But let me see, it's hard to do one-handed. Let me see, and I ain't touching them. Okay, first off, I'm not touching them. Look,
Boom.
getting-
Point 0.05.
0.49.
Yeah.
It says zero. Well, it's
Anyway, you
what
get
happened?
various
Right,
charges
first of all, hold on.
What's your What settings is your voltmeter on?
It's on 1.5 volt.
Right, Brian, just hold them up. Just start off by just holding the two things up in the air.
Here, how about this? There's a ladder. See the ladder?
Yeah, we can see the ladder.
See, they're hanging on copper wires.
And the
that are
wires
sitting on
they're hanging
cardboard,
on.
They're not touching the ladder. They're both sitting on cardboard.
Right.
They're not touching the ladder. See, and they're grounded. And there's a current, just like I said. It's called an earth battery, but that's
Hold up,
different.
the cardboard
current.
on the right. Can you check to make sure the corner isn't touching the ladder?
Yeah, and the ladder's fiberglass, just so you know. But yeah, it's close.
Okay.
But it's not. Look, I promise.
Okay, it's close.
But that was fair.
Fucking
That was fair. I
close.
did have to pull it off the corner. But yeah. It's and the sides are fiberglass and painted anyway. But
There you go.
yeah, that's
Earth current
the
confirmed.
Earth current, boom.
Yeah, so I'm just telling you, man. And guess what? Guess what, y'all? One of them automatically acts like a negative. The other one automatically acts like a positive. I don't know what causes that. I'm sure they might, but as soon as they touch, they zero out, and then they start. Then they build up charge again. They will repel. The lights will repel, but there's still a charge coming out of the ground. He's got his shit grounded. He's getting a charge. I don't care what kind of cage he's got it in. Getting current from the ground, no matter how small, whatever. It's so at least vary that. Maybe I'm wrong, about that.
Okay, so
At
what you need
least
to do
Brian's out
is
there doing something.
take the rod,
Use stuff to
dig it up.
non-conductive, right?
Hold up, Brian. Take the rod, dig it up, and put it somewhere else.
So hold on, Brian. From each one of the.
Dude, it took me forever to.
You got to reproduce it.
Yeah, hold on,
But
Brian.
I'll do that, but not right now. I got to charge my phone, guys. I got to turn this camera off. I got.
Okay, but Brian, are you saying that there are two wires, one wire going from the one lead thing going to the ground thing, and then there's another wire going from the other lead thing to the ground? Is that what you're saying?
No, there was one ground with two wires.
Right, easy. That's what I check. Yes, are there two wires? One going from the ground to one of the lead things, and another wire going from the ground to the other lead thing.
Yep, that's what it is right now. I was gonna vary it and twist them and ground one. I got one copper and one iron rebar, and then I was gonna tie them both to the iron, and then tie them both to the copper, and just try it every different way. But I got charged a little bit just off the one plate by itself. A little bit of charge, man. It creates a charge. I'm not sure that's what's causing the shit, but it does need to be varied, in my opinion.
Hey, let me read a couple things now. Since there's a slight lull there, I'm going to take advantage of it. C4, Data already got this wrong on Jose's earlier. Facepalm.
He doesn't know what period and frequencies are. Oh my God.
And then there was one from, thank you very much, C4, appreciate that. One from B-Ball, I'm scrolling. Oh, Godzilla, shit, I didn't even see that. I'm glad I scrolled up. Godzilla, shout out, man, thank you. Good show, Brandon. Would have been perfect one if Rumpus never showed. Ouch.
Yeah, sorry to bring a bit of reality to you, whoever that Godzilla. Sorry about that.
Godzilla's the man, thank you, or the woman, I'm not sure. Thank you, Godzilla. B-Ball for life, US $5. Rumpus, remember, you're talking to Brian, someone who thinks Puerto Rico is right off the coast of South Carolina. Well, globally speaking,
well,
Brian's right.
Thanks, B-Ball. I'll try and remember that.
That's it. Thank you, guys.
Ain't it? Where is Puerto Rico? I thought it was. I mean, when I looked it up, it looked like it was off the coast. It's north of where I'm at. And dude, I never knew that. I never knew the Bahamas were just barely west of. East of freaking Fort Lauderdale. You could get there in a boat in about an hour and a half if you're going, a fast boat. But it's really, if you went to Freeport, man, you just leave Fort Lauderdale. Man, they don't tell us these things because they know we'd be over there all the time, dude. If we knew that
they
the
don't
Bahamas
tell
was that
you
damn
this.
close.
Yeah. All these people, you're not allowed to buy any maps, of course, Brian, or you're not allowed to look at Google Earth.
Yeah. I've got maps of all the waters around here. I've been in all the waters on the west coast of Florida, east coast, and they just fail to put the Bahamas on any of them. I'm not saying they hit it, but they damn sure don't advertise it. How about that?
Well, the climate of Florida and Bahamas aren't that different.
Yeah.
All right, well, let's look at the map here. Florida, the Bahamas, yeah, they're right over there. Yeah, I kind of thought they were further south too in my mind, but yeah, I guess you're right, Brian. Puerto Rico, it's pretty close to the coast of South Carolina. We'll give Brian a partial credit on that. It's not that far away. Come on, guys.
What? It's about 1,000 miles?
600. Yeah.
You're about 1,000 miles.
750
sideways.
to 1,000. Yeah.
It's 1,000 miles away.
Well, that's only like 4% of the Earth's circumference.
You can cross the whole of Europe in 1,000 miles.
It's not in the tropics, though. It's not in the tropics.
It's not in the tropics.
Yes, it is in the tropics.
Oh wait, yeah, it is.
Puerto
What are you
Rico
talking about? Haiti.
Puerto Rico
right
is in the tropics.
Wait a minute.
I bet you they'll let you go to Haiti, Brian.
You were saying it's only due to the perspective of the eye, so that's got to be less than like 1%. So it's really not that far, right? Because
wait, who said it? Who said it's in?
Exactly.
Who said it's in the tropics? Is it,
it's in the tropics.
It's off the coast of Carolina, but it's in the tropics.
It's not off the coast of Carolina, you moron.
But Rumpus,
That's
we
the
don't actually
problem.
measure the correct angle. We only measure the apparent angle.
Oh,
and, it's not that far.
Yeah, maybe
right?
I'm wrong. I thought it was. I thought I looked off the map and seen it over beside Carolina. I guess, we're all wrong about something. But
you're wrong about everything, Brian.
Oh, shut up. Shut up. I wasn't wrong about getting charged off the hanging lead balls, was I?
Well, we haven't quite pinned that down. I'll be interested. I must admit, I'd be quite interested.
About creating a pressure gradient inside of a container, either was I. So when it counts, I'm on point, dog.
What was the pressure? What's your claim about pressure gradient?
You ain't subscribed to my channel, are you? You are not subscribed to my channel, are you?
Well, the trouble is, there's so much
I do
idiocy coming.
experiments all the time, dude. Okay, little shit.
Well, can you quickly summarize the pressure gradient? Quickly, can you give me 10 seconds?
Unlike the Globers, Brian actually does demonstrations.
Okay, don't
though.
tell me then.
I'll give him
Don't
that.
tell me, I won't look.
Yeah, Brian is a scientist.
I ain't trying to be a scientist. I just like to see shit. I hate hearing bullshit, and that's all I hear from y'all motherfuckers. So we like to see shit over at this channel. You hear me?
Word.
Yeah.
Straight up, talk to him.
Not no
I mean, we know
fucking
there's a pressure
diagram.
gradient to the atmosphere. I don't quite understand why you think you're
Although we
generating a
love
new one, but
diagrams,
there's a pressure
The
gradient.
atmosphere is contained.
No, it's not.
Wait a
Show
minute,
me
did
the
I just
container.
hear a
globe earther use a
Show me the container. Show me the container, Brian. There's no container.
Yeah,
I got
is that a derogatory term, a scientist?
Anyone
I'm
asks,
supposed to be
Brian
a general,
leaks
man.
science.
Sort this all out for us now. Just do a little diagram.
Yeah, I can do that if you like. Show you
Yeah.
the pressure and density gradient of the atmosphere. There is one, so I don't
We'll
quite
get this
know
shit
what.
squared away
Brian-
right now with this diagram.
Friday night
Oh,
diagram.
well,
Yeah, there's
Yeah,
pressure
I'm
and density gradients in all containers that have atmosphere in them. So
That's-
what?
yeah,
What's the diagram going to be of?
You're absolutely right, Hank. Well, I haven't quite had a cause to show diagram. Hank's made an intelligent comment. Indeed, even in a 1 foot high box, there is actually a very small pressure gradient from the top to the bottom due to gravity. So he's absolutely correct there, Hank.
Right, so where's your box? Where's your container?
Where? Sorry, what?
Yeah,
There's a
where's
pressure
your container in the globe Earth model?
There isn't one.
Oh, well, how do you have gas pressure?
Because you don't need a container for gas pressure.
Can you demonstrate that? I got some propane to sell you.
Because the atmosphere has gas pressure and it has no container. Sorted.
Rumpus.
Oh, that's circular reasoning. You thought I didn't
No, it's
know
not.
that.
No,
huh,
it's an
Rumpus?
empirical fact.
Yeah, it
No,
is.
it's an empirical.
Because
No, it's not.
Hold on.
No,
I just
hold on.
made a
You
claim.
hold on.
Let me back
It's
up.
an empirical fact. There is no container. There is an empirical fact.
Listen, I posted
with no
the video of
theory
gas pressure
there
in
is
general, bro.
no
I posted it in
container.
general.
There
Mikey,
is
we
no
can't hear you
container.
because two other people are talking.
There is no container. That's an empirical fact. No, we can
Rumpus,
establish
I
that.
posted it in general. Rumpus, I posted in general a gas pressure gradient in a container. Now you demonstrate one not in a container.
Okay.
The atmosphere.
Wait, stop. Hold on.
There is no container in the atmosphere.
Are you asking him to?
You don't know that.
We do know that because we've been
You
up
don't
there.
know
We
that.
know
There
there's
could be
no
a container
container.
all the way up.
Even flat earthers have sent balloons up there, and there's no
There's
container.
got to be containment,
we?
or the
You got
gas
a mouse
pressure
in
would
your
keep
pocket?
going.
No,
There's no
you've
way.
made
It's
that
got to
up.
be contained somewhere.
You've made that up. That's not the case.
There's no evidence of a container. You don't prove
Correct.
a negative. You provide evidence for the thing. There's no
Correct.
evidence of a container.
Watch my
Rumpus's
video and that'll
I
tell you
tried
otherwise.
to,
'Cause
and
you
I
can't
got
demonstrate
rumpus.
it. We can.
I
All
tried
this shit
to
y'all
back
claim,
up
y'all
my
can't
claim.
demonstrate none of it,
Everything
man.
Clear everything up for us.
I tried to back up my claim, and I got rumpus. Is it okay if I back up my claim now?
Back up your claim, Hank. If you think there's a
so
container, show us where this
Guys,
container
let
is.
Hank go.
Okay, so I can show you that you need a container for gas pressure. When I sell you propane, you're going to need the propane accessories. You're not just
No.
going to show up. Hold on,
all
let
you've
me
done
finish.
is to show
Hold
that's
on,
one way.
Hold
No,
on.
Yeah, I know
Rumpus,
what you
I
made
know
your
you're
point. No, we
trying to live
understand your
up to your
point.
name.
We understand your point.
I haven't
All
made
you've
my
demonstrated,
point yet.
that's one way of getting
I
gas
haven't
pressure.
made my
But
point
that
yet.
doesn't stop there
I
being
haven't-
other ways of getting gas
haven't
pressure.
made my point yet.
You have. Okay,
I
go ahead.
haven't made my point yet. Okay, so you're not just going to show up to the propane salesman with your hands out, right, and hand him some money and get your propane.
Yeah.
You're going to need
You're just
a
saying the
tank,
same thing.
right?
You're
So
not developing your point.
Why do you need a tank? Why do you need
Right,
a tank?
because without having a very large body, if you had something like a portable black hole with you, then you wouldn't need a container. You could put you could hand over your portable black hole. Hold on, and then all the gas would then accumulate on it. But what you're saying is because you need a gas container for your propane, you're therefore saying you always need a container. No, that's just one way of getting gas pressure.
Is a
That does not.
theoretical
Hold on,
black
let me finish
hole
my sentence.
container.
Nearly finish my sentence. That does not exclude the possibility of there being other ways
Well,
of
can you
getting gas
mention?
pressure.
Can you mention any other way?
Gravity, and we know
That was
the
the chopped and
atmosphere.
And
screwed
gravity,
remix.
gravity
We
is
know
not
we've
gonna
got
hold
gas
the propane
pressure.
down.
Is gravity
we've
the
got
thing in
gas
question,
pressure.
though?
We
Is
know
gravity
we've
the
got
thing in
gas
question?
pressure.
Be
We
practical.
know we've got gas pressure in the atmosphere, and we know we haven't got a container. Therefore, you can have
You don't
gas
know that.
pressure
That's
without
Rumpus,
You
you're
don't know that.
confounding
Where is it for you
theoretical
to
with
claim gravity
actual.
when there's very debate?
is about that. Gravity is one of the things in question. You keep on circle. You keep on using circular logic. Everybody tells
Stand
you,
on some
and you don't understand.
scales. Stand on some scales. You measure the force of gravity on your scales.
What I'm telling you is that you can't keep asserting the answers.
Theoretical shit.
You can't keep asserting the answers. Have to do with the questions that we are asking you.
It's an
the shape
empirical
of the
fact
Earth
that your
and
scales
gravity
in
are
your
the things in
bathroom measure a
question.
force.
And you keep giving us
I
the
just
same
posted
answers.
a Harvard link. I just posted a Harvard link that completely
It's an
debunks
empirical
gravity.
fact that the scales in your bathroom
If it was an empirical fact, you would not be here every fucking day, you idiot.
Well, no, I'm just trying to spread the knowledge and science. It's not my fault you're
No,
stupid
I
and
just
ignorant.
posted science, right? I just posted
Okay.
Harvard.
What do you
what
posted,
have
Hank?
you got?
What do you posted,
Yeah, I
Hank?
posted a Harvard study, right? Abstract of a Harvard study.
And
and
this
it
is in
says that
general?
when they,
Is this in general,
yeah,
Hank?
at the top. Yeah, at the top.
Okay. Oh, gotcha.
Right? And it
Right,
completely
yeah, okay.
demolishes gravity. Because what are they looking for? Gravitational effects. What do they not find? Gravitational effects.
All right. Well, this is all to do with the dark energy and the
I just killed Cavendish, dude. I just killed Cavendish right in front of your face.
Yeah, this is all. Yeah, I mean, this is all about dark energy.
No,
You're talking about.
no, it's about 0-point energy, not
Exactly,
dark
which is
energy.
related. What they think is responsible for dark energy, and indeed, it's correct. There's this
Well, it's
120.
convenient for them to hijack the thing.
But this has got
destroy
nothing
their
to do with
gravity
what
to
we're
prove
talking
their dark
about.
energy.
This is a completely different subject, Hank. I don't know why you think it's relevant to what we're talking about.
Do you see the part where it says gravitational effects? How are space balls formed in space with gravity, right?
Say that again.
Test the shit on Edison. Which should be
This has got nothing to do. This is to do with large-scale cosmological effects and dark energy and virtual, as you say, 0-point energy, which we believe to be the result of virtual particles and things and dark energy. That's a completely different subject from measuring gravity on the Earth and knowing it's there and being able to measure it on your bathroom scales. I don't know quite why you think this is in any way relevant.
Okay, can you read it for the class? Do you mind?
You want me to read it out? Quantum field theory predicts a very large energy density for the vacuum, and this density should have large gravitational effects.
All right,
However,
stop
these
right
effects
there. What are we talking about? Gravitational effects.
Well, this is this is to do with 0-point energy, and so we've got a problem
Right,
with a
but we're
quantum.
talking about gravitational effects according to the first sentence, right?
Okay, so this. Let me just. Quantum field theory predicts that this 0-point energy will be very large, and we don't see that. That's a problem with quantum field theory.
No, it's a problem with the gravitational effects because
No,
however these effects are hold on. However, these effects are not observed. What effects? Gravitational
Quantum
effects.
field theory.
And the discrepancy between theory and
it's saying
observation.
we don't. Hold on. No, it's saying we do not see the gravitational effects of quantum field theory that it predicts. So there's a problem with that particular theory.
No, there's a problem. Okay, the discrepancy is
we do see gravity, but hold on. You've seen scales. You've got on scales. You see it measures the force of gravity. So we know it exists. And we know
it
which
measures
value
the
it is.
relative density
And
for
it's
it. Brandon gave you the formula
correctly predicted
like last week.
by Newton
Rumpus.
and by. Hold on, let me just finish my sentence, Jeremy. I'll come back to you. It's correctly predicted. The value you see on the scales is correctly predicted by Newton and correctly predicted by Einstein in the theory of general relativity. But it's not. This quantum field theory does not give a correct prediction. So there's a problem with that particular theory.
Dude, give up on all that relativity shit. Give our youth something to fucking work on, you old dirty bastard.
So this is a vacuum catastrophe, an element exposition of the cosmological constant problem. So is this the quantum field problem or is it the cosmological constant problem?
Well, it's trying to account for the cosmological constant. There was trying to be an explanation for the cosmological constant via quantum field theory. And at the moment, we've got this huge discrepancy. Quantum field theory, as it says there, predicts enormous gravitational effects that we do not see. Therefore, there is a problem with that particular quantum field theory. But the gravity we do
is there's no. Hold on, bro. There is no generally accepted explanation for the discrepancy.
Correct.
So they don't know what they don't know how to fix the problem is, right?
Correct.
And it goes on to state that let's see.
So in other words, there's a discrepancy.
Hold on. As it usually stated, the problem requires knowledge of the quantum field theory, general relativity, topics not normally studied by undergraduates.
So the problem.
Right? So.
Right, can I just respond?
Yeah, I'm almost
Go
done.
ahead, go ahead
just
then.
Be patient, brother.
Okay,
right?
Go ahead.
Yeah, so this problem and the gravitational theory, the problem is gravitational theory is not an experimental science when quantum physics is.
Yes, it is. No, of course it is. Right, so the problem here, the problem.
Before you go on a tangent,
I want to respond to Hank. You can get a chance in a second, Matrix.
I'm going to ask you one thing.
No,
before you respond,
just remember the question. Remember the question, and you can be with you in 10 seconds.
All right.
So what they're saying here, right? So what they're saying here is that the quantum field theory disagrees with the general theory of relativity, but the general theory of relativity agrees with Newton, and it agrees with what we measure. So those three things work. Measurements we see in the real world, quantum, general theory of relativity, Newton. Hold on. No, the discrepancy is between the quantum field theory of this virtual point energy and everything else. So there's a problem with that theory. That's exactly what it says.
Okay, I wanted to ask you about the discrepancy.
That's your understanding of it.
No, you don't understand what it's saying.
Rumpus, let me ask you my question about the discrepancy. Is the discrepancy, is it enough to disregard the field? The field of study that we're talking about where could you get with the discrepancy, right? Is it enough to invalidate the field itself?
No, because quantum field theory.
Hold on.
Can I just respond to that, please, Hank? So the quantum field. I'll be only a few seconds. Quantum field theory gets lots of things right, but it makes a prediction in this regard about gravitational effects that are not correct. So it's not correct in this part, but it's correct in so much else that we use. And for instance, it's required to understand that to get semiconductors and things and computers to work. But in this particular area, because there's no quantum field theory for gravity, so we're in an area, cutting edge of science here, and it's not working at the moment. But the general theory of relativity works, Newton's theory works, and what we see works. All those three things agree. Go ahead, Hank.
Have you ever played Sudoku?
Oh my God, how is that relevant?
Yeah,
I'll make it relevant.
So
have you played Sudoku on evil or like on really hard?
No.
Okay. If you were to play Sudoku on really hard, you'll come to a point where you're gonna have to like make a guess as to what number it is. Okay, so you make a guess, you carry on, you keep on adding the things, and like it works, right? Until if it's wrong, you have a discrepancy, and you don't know which exact number that you got wrong because you don't know like which one set it off. You might have to the guess might have been right, but then the second one after one you don't know, or you may be guessing multiple ones. The point is you don't know what's wrong with the thing. We just know there's a mistake. We don't know how widespread the problem is.
You mean you can't pinpoint exactly where it went wrong?
You just have to kind of like go back and look at everything you're certain of, and then the part where you guessed or kind of like fibbed on, we're gonna have to completely revamp it. And that's basically what happened.
The point is that general theory of relativity and Newton's theory of gravitation and what we see all agree. The quantum field theory is the one that's not working, and we need to obviously come up and prove that.
Okay, I want to say that quantum field theory is an experimental science that they use actual scientific experiments, right? So
we do experiments in general theory. We do experiments in general theory of relativity. Orbit of Mercury, bending of light by stars, the redshift, the gravitational redshift, what frame dragging. There's about 10 experiments. There are 10 experiments. There are 10 experiments you can do to validate the general theory of relativity. It is an experimental science.
So what causes the orbit of Mercury?
The bending of space-time.
Okay, so let's remove that from the equation, right? Because that's our independent variable, right? Let's remove that from the equation and see if it stops. Oh, you can't do that. That's not science.
It's just science.
You can't manipulate space.
Well, there are things called natural experiments. We know, for instance, the general theory of relativity makes some predictions about how the orbit of Mercury will change, how the orbit of the Earth will change. And so we do have an independent variable. Hold on. Let me finish. So the radius is our independent variable. So we can say what effect will be is dependent on the radius of your planet. So we've got a natural experiment here. We've got planets at different radii. So that's our independent variable. The general theory of relativity says that depending on the radius away from a body like the sun, the perihelion, which is what we're talking about here, the orbital precession, how the perihelion moves for Mercury and how it will behave for the Earth. The Earth also has an effect as well. And what we see is that for all the planets, they agree with the predictions made by general theory of relativity. So we do have an independent variable. It's a natural one. It's the distance for all those different planets. And we can test those, and they all agree with Einstein's theories.
Okay, so how do you manipulate the distance? So can we push
You
Jupiter
pick a
out
different
further
planet.
past?
You've already got 8 different planets that you can pick from. Those are variations in your independent variable of radius.
Well, bam! It's called natural variation. It's called natural variation. They do the exact same thing in animal science and biology.
So we didn't have to do it. We can just use those existing independent variables, those existing differences in planets, and say that we're doing an experiment with one planet, Mercury. We take that as our distance, then we say, oh, now I'm going to use another planet with a different radius. We get a different result. Oh, it still matches what the general theory of relativity says, and then we go off to Neptune and we get the results.
That's assuming you don't question the radius of Venus and Mercury itself.
So would you like to try to bring into question biology, for example? Because biology uses natural variation all the time to test for causation.
Yeah.
So who brought up Sudoku?
Me.
Who are you?
Me.
Yes, percentage.
What's your name?
Oh God.
What's up?
Percentage.
Do you want to go in a room together or something? Do you want to go into a room together and have a private chat?
I wonder why he obfuscated for you. I'm just wondering why he's obfuscated.
Let me give you a good example. Hank. If you want to isolate a phenotype, for example, you need to find its genotype. You don't have to do genetic engineering in order to find and isolate which particular gene causes a phenotype. You can just isolate it based on your simple analysis of the gene and then its occurrence together with the phenotype. It's that easy. You didn't have to vary anything, but you performed.
Can you do that with Mercury and Mars? Can you do that with Mercury, Mars, and Venus? Can you do that? Can you isolate and all that?
You can find a particular radius variable, right, and a value to that, and then you can find different ones and say, okay, well, what's the difference here? What is its effects difference? And then you can measure that, just like in biology.
The first step. How do we get the radius? How do we start? How do we start with the radius?
Of what?
Of anything. I mentioned Mercury, Venus, and you say, oh, we start with the radius. I want to understand, how do we start with the radius?
So when you mean that, do you mean how do you work out what the radius is for all the planets? Is that what you're asking?
Yes, of course. How do we start with that?
Right.
You say we start with the radius. How do we acquire the radius?
Okay. Well, from Kepler's laws, we know there's a relationship between the radius and the period. We know the distance to the sun. We know how much it weighs. And therefore, you can determine from Kepler's laws, once you know how much the sun weighs from the orbital period, what the radius is. And we can also measure these things. We bounce radio beams off.
You know how much the sun weighs?
Hold on. Nearly 5 more seconds. We can do, fundamentally, there are many different ways of working out the radius, but one of the most easy ones to understand is like using radar. We can bounce radio beams off Venus, off Mars, and we have done these things off the moon. We can work out all these distances, no problem. Go ahead.
Okay, I appreciate your answer on Rumpus. But it still falls under the same circle of logic that I reminded you earlier, right? You just said we know the distance to the sun. We know how much the sun weighs. These are the things in question, and you can only answer every time we give you a question. You give us the same circle of logic, the same thing of the things in question.
But it's not circular logic. To bounce radio beams. Hold on.
Let me ask. How do we get the distance to the sun, please?
Right, bouncing radio beams off it, and we time how long it takes a radio beam to go to the sun and back, and therefore we know the time and the speed of light. We can easily work out the distance. It's a piece of very easy thing to do.
We'll see.
And assuming that's correct, how could we get the weight of it?
Because the period, how long the Earth takes to go around the Earth, around the sun, is directly related to the mass of the sun. There's a very simple formula to determine that.
And I'm assuming you already have those measurements, right? You already have every calculation of every day that you are able to add it up, and it would agree with your calculations, right?
Yeah, and every piece of independently obtained evidence all agrees to give you the same answer. Therefore, we know they're correct.
Just because a group of people give you the same answer to something doesn't necessarily correlate with it being correct.
Completely different methods of obtaining the distance to the sun gives you the same answer. Therefore, we have very high confidence of the distance to the sun.
Well, you already gave me radio waves, right? What is the other method? Give me another method.
Okay, another method is to do what they did in 1681 is what Cassini did. He worked out the distance to Mars by using a parallax method. They had sent off some people to French Guiana and from Paris, then using parallax, hopefully you're familiar with that, triangulation in effect, to get the distance to Mars. Then from Kepler's laws, knowing the distance, you then got the distance to Mars. You then absolutely know that. And once you know that, you then can work out from Kepler's laws the distance to the sun. So that's using triangulation. So using basic geometry.
Mars, the sun, Venus. These are all the things in question, right? So when you tell me, I know the answer to the sun with the answer to Mars or Venus.
Yeah, you can work it
get
out.
how that circular logic? Because I'm going to keep continuing to ask you, how do we get those
independent ways? Look, there's one way you can do it directly by bouncing radio beams off the sun. There is another way, as I said, using triangulation. Are you familiar with triangulation?
Yeah, can you please explain triangulation? How does triangulation work?
Well, you need a baseline, and then you need to work out the angle to something you're observing. And you can do that. By doing that, you can work out the distance to Mars by just simple triangulation.
Bouncing light 93 million miles to bounce off gas. That's at extreme high temperatures. Come back 93 million miles.
And even so, if you could get away with a percentage, I want to understand how is it exactly that they get the weight of it of that?
Well, hold on, you keep on changing. So you accept So I've just pointed out we use triangulation to get the distance to Mars. Very easy. Well, actually, you do need the Mars in the right location. You use it in opposition. In 1681.
I'm not an expert, right? So I'm triangulation.
But you understand the triangulation. You just need to know that the distance between two things and the angles you see to
the. But the distance between the things is the things in question. Wrong path.
No.
Logic again.
No, it's not.
How do we get this?
To Mars. Hold on. We're working out the distance to Mars here. That's not dependent on anything else. You have a baseline. And then you know the length of the distance on the baseline, and then you look at the angles from 2 points on the Earth to Mars, and using triangulation, you then know the distance to Mars. Having got the distance to Mars from the Earth, you then using Kepler's laws to work out how far it is from the Sun, which is independent, a completely different way of doing it to get the distance to the Sun from bouncing radio beams off the Sun. I mean, there's two completely separate means of working out the distance to the Sun, and they both agree on the same thing.
I got these lead plates. I'm grounded to the same rod, and I'm still getting fucking charged. I got them grounded to the same rod.
Because there's an atmosphere. Where's the atmosphere, Rumpus? Doesn't that cause refraction?
The point is, you calling it into question.
Right, but the
point into question does not mean it's in doubt.
Are you not in a flat Earth debate at this moment, man? Don't you think that's enough doubt? You must be insane, then.
I'm trying to answer you, Hank. Right. So, in other words, when you make the observation of Mars, the angle from two sides of the planet, it's very high up because when you do it, you have it in opposition, which means that the baseline is 90 degrees to it, which means, and the angle you're looking at the Mars, it's almost
90 degrees above locations.
It's very nearly in opposition when they make the observation, almost 90 degrees directly above, almost. So therefore, refraction, hopefully you know that if you're looking through, 90 degrees, if you're looking, for instance, if you're looking directly down in water, there is no refraction effect. So similarly, when you're making the observation of Mars from two sides of the thing and you've got it in opposition, it's almost directly sort of, going through the atmosphere at 90 degrees. So the refraction issues are, effectively zero. Just like looking straight down through water, there's no refraction effects. It's only when you're looking side onto the medium that you get refraction effects. So, and as I say,
Brian, do you know, Brian Leakey, do you know if anybody has ever attempted to throw a radio wave from land to land as far as possible? Have we tried that to see if that's even possible?
Yeah.
To just get like a straight shot from
some guy named Marconi. Some guy named Marconi.
Yeah. They try to do it all the time, and even in airplanes, there's still a freaking radio shadow.
Anybody got a link to one of those so I could check it out?
Yeah, ask any pilot. Go up.
Are you talking about the radio signal across the Atlantic Ocean from?
I don't mean necessarily across the ocean. I'm just talking about land, right? We're talking about trying to throw signals from here to another planet. Has anybody just accomplished this on the Earth? I'm just asking.
Yeah, I don't believe that. I don't believe they're bouncing something off a bar. How could they even aim it? For one, two. I mean, there's a million problems with that shit, dude. That's why they'll never show you.
But that's what I'm saying. Let's question them be able to do it from land to land first.
So,
and then let's consider.
So, what are you asking for again, So I didn't quite pick that up.
I want to know: is there some sort of experiment for where somebody decided to, just like you guys say, you guys throw a radio wave? Yeah. All right. Yeah. Is that done ever in land, like from a receiver to another? Just from very far distances away. Do you guys know of that happening?
Well, that's what radar is in effect. If you want a short distance, that's all radar. I mean, it's just behaving like radar. This bouncing stuff off the sun is no different to how radar works, in effect.
But all right, but you're talking about something in atmosphere versus something. Who knows what else? You know what I'm saying? I can't even say a vacuum because according to you guys, it isn't even that, right?
What isn't even that? It's effectively a vacuum.
It's not a vacuum because the
Space
sun
is
has
effectively
its
a vacuum.
own atmosphere.
For all intents and purposes, we can treat it as a pure vacuum. But it's not
Rumpus,
quite
what are you
pure.
talking about? What about the heliosphere? That's not a vacuum.
Yeah, but the heliosphere is close to the sun. But in between, I'm presuming he was talking about from the Earth to the sun. That is effectively.
So what causes refraction, right? Difference in temperature. Is the sun hot? Is space cold? What causes refraction?
Well, hold on. When we're hitting the sun,
medium, the density of the medium. So
we're
going from a near perfect vacuum to the Earth's atmosphere. And then the sun's atmosphere
through 90 degrees.
That's a lot of refraction. How do you?
No, it's not. Not if you do it 90 degrees. We're pointing at directly at the sun. So the bit we're going to get signal back from is a bit that's we're hitting at a perpendicular. So we're looking.
The sun
imagine a
can't
football.
be over your head in two places on Earth at the same time.
No one's claimed it is. Well, actually, it can
So
because
how's it at
along a
90
line of
degrees?
longitude.
Double speak.
Along a line of the. Well, but it's not relevant to what we're talking about here. You can point your transmitter at the sun.
It's absolutely relevant.
I don't know why what's that got to do with being in two places? I don't understand your problem at all.
Why is refraction relevant when you're making an argument, but when we make an argument, it's irrelevant or it's
I never dispute
negligible
refraction.
because it's so small.
Well, it depends what you're doing. If you're looking at something like the horizon, it's because you don't understand refraction. If you're looking along the horizon, for instance, when you've got your angle. When you're going along the medium, like when you're looking at something horizon, you've got maximum refraction effects. If you're looking vertically upwards, there is no refraction. Do you not understand that? You don't know about refraction.
How can you say there's no refraction?
Hey, what happened? Did them waves?
Is there differences in temperature?
Hold on, Brian. Let me just hold on just a second, Brian. You clearly don't know anything about refraction. If, for instance, have you seen the videos of where they have a glass block and you're firing a laser through it, and then they put the glass block at 90 degrees to the beam of the laser, and it goes straight through unrefracted. They then rotate the glass block at a little angle, then it starts to refract. So it depends on where the boundary of the medium is and where that meets. And if you meet it perpendicular, there is no refraction. It's just like when you're looking down through water. So if you're looking directly down through water, there is no refraction effect. You only get refraction effect of water if you're looking angled to the surface. Do you not know that?
Right. So the first pole under the Eratosthenes experiment, there's no refraction because it's 90 degrees. I agree. But the second pole, there's refraction. So if the sun's over your head in one spot, hold on. If the sun's over your head in one spot, let's say France, and then you test it somewhere else, another location, it's not going to be directly over your head because it can't be in two places at once. So this is going to cause refraction, which is going to cause error, right? And the fact that the distance is 93 million miles away, that little triangle is going to be such a small, what'd you say, 5 degrees, 0.5 degrees?
0.5 degrees,
of the sun?
So, but the angle
93 million miles, 0.5 degrees. How accurate is that going to be at that distance?
Right. What you're talking about is
the Earth has traveled 19,200 miles in that amount of time.
Hold on, Brian. Remember that point, Brian. Remember your question and come back to me when I just. Right, with the Eratosthenes, you're completely correct. Something like the way he did it from Cyrene, where it was directly overhead, and then he made the other observation, Alexandria, which is a couple hundred miles, possibly a bit more than that, 300 or 400 miles further north. So there is a difference in angle, but it means that the difference in angle is only it's only going to be about 5 degrees. When you're looking through the atmosphere, because again, if you're using high angles, the refraction effect is much, much less. And particularly when you're going through air, because the refraction effect of air is much less than water. So you're going to get much more refraction effect through water. So when you're looking at a high angle, as he was doing, the fact that it's 5 degrees off vertical means that the refraction effects are tiny, particularly because air doesn't refract anything very much. So the error introduced by refraction for that particular experiment is very small. It's not small when you're looking at the horizon, when you're looking at 90 degrees and you're going along the medium. So, Brian, what was your question?
Okay, so if it's just real fast, I just want to add this one last thing. So, if it is affected a lot at the horizon, then when people look at the horizon to measure the curvature of the Earth, it's going to vary, right, because of all that refraction. So, therefore, there is no. Hold on, let me finish. So, therefore, there is no geometric horizon that you can point to, right, because it's a refracted horizon. So, people like Al-Burundi, who measured the radius by looking at the horizon, And what refracted horizon?
Okay, I'll
do
tell
look
you the
at?
answer.
The
Right, now,
actual horizon.
I'm amazed you
or
don't
the
know the
reflected?
answer to this. I'm amazed you're making this point. When everybody raises this problem, everybody then responds by saying Al Biruni did it from top of a mountain looking down. You're talking about people like the Black Swan scenario, where they're only 2 or 3 feet above the water level and then looking at 90 degrees. Al Biruni deliberately went up as high as possible. So
Dude, look at
can I
Scott
just,
Dude.
Brian, nearly there. Brian, nearly there.
Dude,
So Brian, nearly there.
you know
Really nearly there. 5
Scott
seconds,
Bay
Brian.
is not at
5
the ground,
seconds,
bro.
Brian. I'm going to finish. Brian, just 5 seconds. So when Al Biruni did it, he did it from the top of a mountain looking down. So he's not looking like a black swan. And the refraction effect is much less. There's still some refraction effects, but it's only a few percent error. So you can get a decent value for the radius of the Earth from getting up from the high mountain looking down.
Different mediums. So, Brian.
Hold on, let Brian have a go. It'll explode, Hank. Let Brian speak, otherwise it'll explode.
Two things, and now I gotta go.
ahead.
Two things. Skunk
Go ahead, Brian.
Bay is up in the air, and it shows refraction for days. Skunk Bay is up in the fucking air. And another thing, if you say you're shooting a sun,
Fix your mic, Brian.
Yeah, Brian, you're shouting.
I gotta go. I gotta go.
Brian, we can't hear you. You're
Fix your
shouting,
mic.
Brian. You're distorted, Brian, because you're shouting. Oh God.
He's gone. Anyway, that's a good note to call it a night on. We're at about 8 o'clock, so we can do final thoughts real quick. But first, Bandsaw Bandit, $2. If there's no sauce, there is no source. Thanks, Bandsaw. Appreciate it. Why don't we start off with final thoughts with exclamation point.
Hey, hey.
What up? Oh, is that you, Crit?
Yeah.
Oh, hey, man.
Wins every day. Nothing changes around here. The same regurgitated talking points they tried to present in 2016. They're still presenting today. They were still presenting their complete lack of knowledge of logic, reason, and science. They've only got themselves to blame. They've had time to research this stuff, and they don't.
Thank you, Crit. Percentage.
Yo, good show for some of it. That's what it is.
All right, thanks. Percentage. Autodidactic. Oh, never mind. Bandsaw Bandit.
Hey, good show, Brandon, and the vortex continues. Till next time, man.
Indeed, thank you. Karin Kentucky. Oh, if you're talking, we can't hear you. I'll come back. Crit is a dumbass.
Yes. The Earth is not flat. And if you look in the general chat in Discord, you can see Crit admits the Earth is a globe too. So, thanks. See you.
Thank you, Data.
He debunks himself in real time.
Final Crit. Quiet.
I went on to Jose's earlier today. I presented the same formula. Asked Blue for his Cavendish formula, considering it's calculating cycles over a period of time. Same principle. Figured I'd present it to Rumpus as well. Backed it up with where I got it from, right from the teacher's hand. Right from the teacher's hand.
Final
Right
thoughts,
from-
Rumpus. Final thoughts, Rumpus.
He just lied. Yeah, but he just lied blatantly. He never
Well, then
presented
you can
to us-
respond
told
to
us
it
where
in
he got
your
that from.
final thoughts. You can respond to it. then.
Okay, all right.
So I presented it at Blue. Blue got it wrong. He ignored it. I presented to Rumpus, and I backed it up with actual, the written right from the teacher, showing that the formula represents G, little g. And there you go. And I gave everybody the formula to try at home. Take a pendulum, one consistent length of string, time it out for cycles, and you'll see that each object that you run through the cycles do not have a constant rate. They all change and they all vary. Thank you.
Thank you, Gleam. Jace. Jimbo. Matrix.
Oh man, good show today. I want to thank Rumpus for his patience. I see that he's trying to work on that arrogance of his, or it could be that everywhere else they're treating him like shit, so he pretty much has to be nice. But regardless, thank you for your patience, and thank everybody in the panel and everybody else in the chat. All right, thank you, Brandon.
Thanks, Matrix. Sorok. Skeptical. Bob. Rumpus.
Yeah, I don't know. I'm not behaving any differently. Not any, differently from anyone else.
Hey, Rumpus,
yes,
you know
that
you're a princess, right?
Well, I don't like being
You're a
interrupted.
little
This is
princess,
the-
right?
Thoughts,
I
Data.
don't like being
Final
interrupted,
thoughts.
and I don't like deceivers like you, where you're reluctant to tell us where you got. Actually, the formula, I think, and of course, you misrepresented the formula. You got the frequency and the period mixed up, as Blue said. And I know, and in fact, I do believe that the formula you're using is one for that, and it is actually just rearranging the formula that I gave and I actually posted earlier. And if you rearrange it, you do get a formula very similar to the one that you posted. But of the reason you're obviously reluctant to tell us where you got it from and why the value is different, it will explain it in that, because it could be something like working out the period on June thing. We don't know, because Data knows that if he told us where he got it from, it would contradict the point he's making. And he's a deceiving little ignorant git, and he doesn't know the difference between frequency and period. Finished.
Thanks, Rumpus.
No one
Tony
trusts
B.
you. Can I?
Sorry, I
I
thought
got
period
skip.
didn't exist in that.
Yeah, I'll come back. Tony, you got anything?
Yeah, a dot doesn't exist, right? A period? That doesn't exist. That's not real.
You talk. I mean, my microphone sucks. Blah 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 blah. Okay, see you. Good show.
Thanks, Tony. Sorry we bagged you.
Sorry, can I be heard?
Data's a moron. That's it. That's all I want to say. Bye.
Thank you. Hank Hill, you got final thoughts?
Oh, yeah. Flat earthers try not to obfuscate other flat earthers when they're making their arguments and they're pinning down Glovers. I think that would be great. Please and thank you.
Thank you. Rob. Rob Keane. Skeptical.
Great show, even though it came a bit late. So, what I want to say, all the Earth is flat, it's immeasurably flat and stationary. And Rumpus, stop lying to people, stop deceiving them, right? That's all I want to say. Yeah.
Thank you very much. All right, Rob, you there? Last chance. No? Damn. Thanks, guys. I appreciate the panel joining tonight. It's a good week. And we'll be back on Monday. Everybody enjoy their weekend, and I'll come back.
Damn it, Brandon, I'm here.
Oh, damn it, Rob. Go ahead.
Damn it, Rob. No, this is just real quick. I love the show. This is for percentage. The water level creates a straight line. When it no longer creates a straight line, we wouldn't call it horizontal. The water level is all we need.
And water level is curved.
Thanks, Rob. All right, guys, I'll be back. I'm going to record the after show.
Prove it.
All right. Thank you, everybody. Thanks to the mods in the chat. Chat seemed pretty chill tonight. Appreciate that. You guys have a good weekend. Enjoy. Hopefully there's good weather wherever you're at. And I'm going to get some rest, and we'll see you on Monday. Have a good one.